chapter 15 in 10th standard maths is surface areas and volumes. In some state school textbooks, the chapter number could be different. It could be chapter number 5 or chapter number 10. But all state schools who have implemented national education policy will have same syllabus. Content will be the same, though chapter number could vary. Now let us recall what is area of some figures. Okay, now what is the area of square given by? So let us suppose the sides of an square is a. Okay, now what is the area of the square given by? So it is a into a. And what about rectangle? Suppose if b is the breadth and L is the length of the rectangle. What is the area given by? Area is given by length into breadth. Okay, length into breadth is the area. Now what about circle? So if R is the radius of the circle, what is the area given by? So area is given by pi into r square. Okay. Now what about cylinder? So cylinder is like this. In the top there is a circle, and bottom also there is a circle like this. Okay. Let us say h is the height of the cylinder. Now what is the area of the top surface? It is pi r square. If r is the radius, then the area of the top surface is pi r square. The area of the bottom surface is also pi r square, and the curved region also has got some area. What is this area? Suppose if you remove the bottom and top portion and cut the cylinder and spread it, you get a rectangle like this. Okay, so and dimension will be h. This is h. Okay, since the height of cylinder is h, this height will be h. And what about this length? This length will be equal to 2 pi r. So 2 pi r is nothing but the circumference of the circle, 2 pi r. So for the top and for the bottom circle, 2 pi r is the circumference. Okay, so therefore when I remove the top and bottom portion and after cutting the cylinder and after spreading it, I get a rectangle whose height will be h and another side will be 2 pi r. Now this is a rectangle. This is purely a rectangle. Now what is the area of this one? Area of a rectangle is given by side into height, length into breadth, or area is pi into 2 pi r, or simply 2 pi r h is the area, curved surface area of the cylinder. Similarly, what about cone? So cone is like this, and at the bottom there will be a circle. So if L is the slant height and R is the radius of the bottom circle, so now the bottom circle has an area of 2 pi r square, as you know, and the curved region also has got some area. What is that area? How to find it? It's very simple. So here in the bottom circle, the circumference is given by 2 pi r. Okay, now if you remove the bottom and if you cut the cone vertically and if you spread it, you get shape like this. Okay, you get shape like this. Since the slant height is L, so here it is L, and this length you will get as 2 pi r, 2 pi r. And actually, if from this point, if you draw a circle with a ls radius, you get like this. Okay, actually this portion is nothing but sector of the circle whose radius is L. Now what is the area of this circle? Area of this circle is given by pi r square is the area. That means pi into L square, because L square is the radius. Okay, so area of this circle is pi L square. And what about the circumference of this circle? It is 2 pi r is the circumference. Now since L is the radius, circumference will be 2 pi L. Okay, now this I'll take as O. Now see, 2 pi arc length, circumference of 2 pi L gave an area of pi L square. Therefore arc length of 2 pi r, okay, this is arc length. Okay, so therefore arc length of 2 pi r gives 2 pi r into pi L square by 2 pi L. So 2 will get cancelled, pi also will get cancelled, 1 L also will get cancelled. I'll get pi into r into L. So pi into r into L is nothing but the curved surface area of cone. Okay, curved surface area of cylinder is 2 pi r h, and curved surface area of cone is pi r L. Now what about sphere? Okay, sphere is a three-dimensional object. Okay, if r is the radius of the sphere, then the curved surface area, okay, curved surface area of sphere is given by 4 times of pi r square. Okay, this is curved surface area. Area of circle is given by pi r square. Area of sphere is given by 4 times of pi r square. Circle is a two-dimensional plane, whereas sphere is a three-dimensional object. Example of sphere is earth, ball. All these are in the form of in the shape of sphere. In your textbook there are some worked examples, just go through it. Now here you can see there is a milk tanker. Now what could be the surface area of this milk tanker? Now this milk tanker I can divide into 3 parts like this as shown here. Okay, the first part is a hemisphere. Hemisphere means half of sphere, and the second part will be a cylinder, and again the third part will be a hemisphere. Now the area of that milk tanker will be area of this hemisphere plus curved surface area of this cylinder, and again the curved surface area of this hemisphere. So you can see total surface area of new solid is curved surface of one hemisphere, that is this hemisphere, then curved surface area of cylinder, this cylinder, then curved surface area of other hemisphere, this one. When I add all this, I'll get the curved surface area of this object or the milk tanker that is shown there. Okay, now what will be the area of this surface area of this test tube? So here also I can divide this test tube into 2 parts, that is one part of a cylinder I can cut like this here. So the top part will be a cylinder, the bottom part will be a hemisphere. So curved surface area of this test tube will be the curved surface area of the cylinder and plus curved surface area of this hemisphere which is at the bottom. So here in this example you can see there is a toy Now what is the curved surface of this toy? So here this toy can be divided into two parts, that is one cone and one hemisphere. So total curved surface area of this toy will be the curved surface area of this cone and the curved surface area of this hemisphere. Now here you can see there's a playing top here which is called lattu or buguri. So here what is the total surface area of this playing top? It will be equal to sum of curved surface area of this cone and sum of and this area of this hemisphere. When I add these two curved surface area, I will get the total area of the playing top. So all these are easy problems, you can just go through it, all are self-explanatory. You should make a habit of reading max textbook also. When you go to higher studies, it will be very helpful. Even if you miss some class, you will be able to study by your own and understand. Exercise 15.1, question number 1. Two cubes, each of volume 64 centimeter cube, are joined to end. Find the surface area of the resulting cuboid. So cube is like this. So this edge we won't be able to see. Now given that the volume of the cube is 64 centimeter cube, okay, so volume is equal to 64 centimeter cube. So what is volume of a cube is given by, suppose if A is the length, okay, or side, okay, so in a cuboid all the sides will be equal to A only, okay, every side will be equal to A. So volume of a cube is given by A into A into A. This is equal to 64. So A into A, this gives actually the area of the base, okay, area of the base into another A gives the height. So base length into breadth into height gives the volume of a cube, okay. Now A into A is equal to 64, or A cube is equal to 64, or A is equal to third root of 64. So 64, if I factorize it, 2 3s are 6, 2 2s are 4, 2 16s are 32, half of 16 is 8, then again half of 8 is 4, then again half of 4 is 2, then 2 1s are 2. So A is equal to third root of, how many 2's are there, 1 2 3 4 5 6. So 64 I can write as 2 into 2 into 2 into 2 into 2 into 2. Now since it's third root of 64, now I can group 3 digits like this, and I can remove 1 2 from here and 1 2 from here I can remove, okay. So A becomes, now 1 2 I'll remove, then another 2 also I'll remove, into third root of 1 is left. So A is equal to 2 into 2 4, third root of 1 is 1 only. So 4 into 1 is 4. So actually each side of this cube is 4 centimeter, okay, 4 centimeter. Now two cubes are joined, okay. Two cubes are joined like this. So these are the visible edges, and there is an invisible edge like this. Okay. Now I should find the surface area of the resulting cuboid. Now here in the first cube, okay, I'll come to the second cube. So there are four faces like this. Okay, if I go in this direction, and one in the first cube also, if I come in this direction, there are four faces. That is top, bottom, front, and end. Four faces. And this is one face, and this is one face. In the left there is one face, and in the right there is one face. Okay, now dimension I came to know, it's all 4. It's all 4 4. Okay, 4 centimeter, like this. Now I should find the surface area of this cube. Now totally how many faces are there? From one cube I am getting 4 plus 1 5. In the another cube I am getting 4 plus 1. Total faces. Therefore total faces, total square faces. Total square faces, how much are there? 5 plus 5. Totally 10 square faces are there. Now what is the area of each face? Area of each face, that is length into breadth, or side into side, or a into a. So a is 4, so into 4 4s are 16. Therefore area of 10 faces is equal to 16 into 10, 160 centimeter square. So volume is given by centimeter cube. Okay, centimeter cube. The unit of volume is centimeter cube, and the unit of area is centimeter square. Okay. Now 10 faces are there, and this is nothing but the surface area of resulting cuboid, 160 centimeter square. And that completes this problem. Exercise 15.1, question number 2. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. So this is a very simple problem. A vessel is made by a sphere and a cylinder. So cylinder is placed on top of the vessel is made by hemisphere and a cylinder. Okay, the cylinder is placed on top of a sphere, and the radius of the hemisphere is 14 centimeter. Okay, and the total height of the vessel is 13 centimeter. Now since the radius of the hemisphere is 14 centimeter, this height of the hemisphere will be half of diameter, that is 7 centimeter. And what will be this height of cylinder? It will be 13 minus 7 is 6. So height of cylinder is 6 centimeter. Now total surface area of vessel is equal to curved surface area of cylinder plus curved surface area of hemisphere, because the vessel is made by cylinder and a hemisphere. Okay, now what is the curved surface area of the cylinder? So this curved surface area of cylinder is given by 2 pi r h. Okay, curved surface area of any cylinder is given by 2 pi r h. 2 pi r is nothing but actually the circumference into height gives the area of the curved surface area of cylinder. So here 2 pi r is So since the diameter of the hemisphere is 14, the diameter of cylinder also is 14, so half of 14 is 7. So 2 into pi into 7 into height of the cylinder is 6, plus curved surface area of the hemisphere is, so what is this surface area of a sphere given by, okay, curved surface area of a sphere is given by pi 4 times of pi r square. Half of that gives curved surface area of hemisphere. So this is 4 by 2. Here 4 by 2 I can cancel, 2 ones are 2, 2 twos are 4. So 2 pi r square. So 2 pi into r is 7. So 7 square. So here I can take 2 pi common, 2 pi, and also 1 7 also I can take. So remaining is 6, plus here 7 is remaining. Okay, this is equal to 2 pi into 7, 6 plus 7, 6 6 12 plus 1 13, okay, into 13 I get. So what is 2 pi? Pi is 22 by 7. I'll substitute that value into 7 into 13. 7 will get cancelled. So 2 into 2, 22 into 2 is 44. 44 into 13. 3 4s are 12. 3 4s are 12 plus 1 13. 1 4s are 4. 1 4s are 4. 2 4 5 6 7 4 5. So 572. 572 centimeter square is the area of the vessel. Total surface area of vessel is 572 centimeter square. Exercise 15.1, question number 3. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. The total height of the toy is 15.5 centimeter. Find the total surface area of the toy. So this is also very simple. So there is a toy and it is made up of a cone and a hemisphere, like the cone and a hemisphere, okay, and the radius of the cone is 3.5. that is from this point it is 3.5, from here till here it is 3.5, is mounted on a hemisphere of same radius. Radius of hemisphere also is same, and total height of the toy is 15.5. so this height, total height of the toy is 15.5 centimeter. Now find the total surface area of the toy. Now total surface area of toy is equal to, now there are two portions. One is curved surface area of cone plus curved surface area of hemisphere. So what is the curved surface area of cone? So curved surface area of cone is given by pi into r into L, where L is the slant height, okay, this is L, slant height. Now before we can proceed, we should find the slant height, that is L. Now I'll draw one perpendicular from top of the cone here, like this. Now since the radius is 3.5, radius of hemisphere is 3.5, here also it is 3.5, and what is this height? So given the radius of hemisphere is 3.5, therefore this is also 3.5, okay, this is 3.5, therefore this will be height of the cone. Height of the cone will be 15.5. 15.5 minus 3.5, so this is 12. So height of the cone is 12, so this is 12. So now what is L? Now here this is a right angle triangle, therefore L square. Now applying Pythagoras theorem, L square is equal to 3.5 the whole square plus 12 the whole square, or L square is equal to, now 3.5 into 3.5, 5 5s are 25, 5 3s are 15, 16, 17, 3 5s are 15, 3 3s are 9 plus 1 10, 5 12 2 1. So 12.25, 12.25 plus 12 square. So 12 square is 12 into 12, 2 2s are 4, 2 1s are 2, then 1 2s are 2, 1 1s are 1, 144 I will get, okay, plus 144. So when I add these two, I'll get, so 144, I'll get 5 2, then 4 5 6, 4 5 6, then 4 1 5. So 156.25 I will get as a L square. Therefore L is equal to square root of 156.25. So now 156.25, so I should find the square root. So 1 1s are 1, so 1 minus 1 is 0, I will take 5 6. So plus 1 I will add, 1 plus 1 2, now 2 2, 22 into 2, 2 2s are 4, 2 2s are 4, 44. So 6 minus 4 is 2, 5 minus 4 is 1. Now 0.25 is there. If I take 25, I should keep that point here, decimal point here. Now I'll add this 2 to this 22. 22 plus 2 is 24. So now 245, 24, I'll take 5. So now 245 into 5, 5 5s are 25, 5 4s are 20, 21, 22, then 5 2s are 10, 11, 12. So I'll get 0. So square root of 156.25 is 12.5. Actually I should get L is equal to plus or minus 12.5, but I'll reject the negative value. I'll take positive value only, because here length can be only positive, slant height can be only positive. So now coming to curved surface area of cone. Curved surface area of cone is given by pi into r into L, pi into r into L, plus curved surface area of hemisphere. Curved surface area of hemisphere. What is the curved surface area of hemisphere? Surface area of sphere is 4 times of pi r square. Half of that will be surface area of hemisphere, and curved surface area of cone is pi into r into L, as I told you. So pi into r into L plus 4 pi r square by 2. Okay. Now substitute all the values. Pi, what is r? R is 3.5, pi into 3.5. What is L? L is 12.5 plus 4 into, now here 2 1s are 2, 2 2s are 4. So I'll get 2 into pi. What is r? 3.5 the whole square. Now can I take anything common? I can take pi common. Pi into 3.5 also I can take common. Now I am left with 12.5 plus 2 into 3.5. So here 3.5 the whole square means 3.5 into 3.5. So 3.5 I have taken common. Now this is equal to pi is 22 by 7 into 3.5. So 12.5 plus 2 5s are 10, 2 6 are 12, plus 1 7. So I'll get 7.0. So here 22 by 7 into 3.5. So 12.5 plus 7 is 19.5 I'll get. So into 19.5. Now 7 1s are 7, 7 5s are 35. So I'll get 0.5. okay, 0.5. Now 22 into 0.5, 22 into 0.5 means half of 22, it becomes half of 22, so it is 11 into 90.5, okay, 22 into 0.5 is 11, okay. Now 19.5 into 11, so 591, again 591, so 5, 14, 9 plus 5 is 14, carry 1, 9, 10, 11, so 2, so 214.5, so 214.5, what is the unit? Unit will be in centimeter square. So total surface area of the toy is 214.5 centimeter square. So length will be in centimeter, area will be in centimeter square, and if volume is there, volume will be in centimeter cube. So you should give correct unit, otherwise you may lose some marks for that, okay. Always area is in centimeters cube or in meters cube or in kilometers cube, that way, okay. Exercise 15.1, question number 4. A cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. So there is a cubical block, okay. So cubical block will be like this. So, and this is the invisible edges. Now given the sides of the cubical block is 7 centimeter, that is 7 7 7 7 like this, okay, everywhere it is 7, and upon this there lies a spherical, sorry, there lies a hemisphere, okay. Hemisphere will be like this, okay. So what is the greatest diameter this hemisphere can have? So since any side of the cubical block is 7 centimeter, the greatest diameter the hemisphere can have is 7 centimeter only, okay. So the greatest diameter of sphere is equal to side of the block, so that is equal to 7 centimeter, okay. Now find the surface area of the solid, okay. Now in this coming to cube, okay, totally how many faces are there in a cube? There are 6 faces, okay. Therefore totally 6 faces are there. Area of each face is equal to side into side, 7 into 7. Therefore area of 6 faces is equal to 6 into 7 into 7, okay. Now coming to hemisphere, what is the area of hemisphere? Area is given by half of 4 pi r square. 4 pi r square is the area of sphere, so half of that will be area of sphere, okay. So this is equal to, now 2 1s are 2, 2 2s are 4, so 2 pi r square, that is equal to 2 pi, okay, 2 pi r square, let it be like this only. Now what is the total area? Total area is equal to 6 into area of each face of cube, okay, plus area of hemisphere, and also we should subtract the area area of the circle formed by the hemisphere. Okay, the base of the hemisphere is a circle. Okay, that area should be subtracted. That area is given by pi r square. Okay, area of circle, I'll write area of circle whose radius is equal to 7 by 2. Okay, diameter of a sphere is 7, so radius will be 7 by 2. Okay, now this is equal to, so 6 into area of each face of cube is 6 into 7 into 7 plus area of hemisphere is 2 pi r square, 2 into 22 by 7. What is r of the sphere? That is 7 by 2. 7 by 2 into r square means 7 by 2. 7 by 2 I'll get. Now minus area of the circle with r as radius, and that area of circle is nothing but the base of the hemisphere. Okay, and that area is common to both hemisphere and cube, so that one I should subtract. So minus area of that area of circle with pi r square with r is equal to 7 by 2. That area will be pi into r square. Okay, so 6 into 7 into 7 plus here 2 into 22 by 7 into 7 by 2 into 7 by 2. Here minus pi is 22 by 7 into r is here 7 by 2. 7 by 2 into 7 by 2. Now this is equal to 6 into 7 into 7, you will get 294. Okay, plus here 7 7 will get cancelled, 2 2 will get cancelled, 2 1s are 2, 2 11s are 22. Now here 7 7 will get cancelled, 2 1s are 2, 2 11s are 22. So I am left with 11 into 7 minus 11 into 7 by 2. So this is equal to 294. Now plus here 11 I can take common, 11 if I take common, 7 minus 7 by 2. So this is equal to 294 plus 11. 7 minus 7 by 2. 7 minus half of 7 is half of 7, that is 3.5 I will get. Okay, 3.5. Okay, 7 by 2 is half of 7, that is 3.5. Okay, 7 minus 3.5 is 3.5 only. Okay, so total now you will get 294 plus 11 into 3.5. So totally you will get 2.5 centimeter square is the answer, total area. And that completes this problem. Exercise 15.1, question number 5. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. So the cube is like this. Let us say the dimension or length are equal to L. That means length, the sides are equal to L, and this is the invisible edge. So length is equal to L, and breadth is also equal to L, and height is also equal to L units. It may be in centimeter or it may be in meters. Okay, everywhere it is L. And out of this, a hemispherical depression is cut out from one face of the cubical wooden block so that the diameter L of the hemisphere is equal to the edge of the cube. Okay, so let us suppose from the top only the hemispherical depression is made. Okay, so from the top the hemispherical depression is made. Okay, this is the hemispherical depression. Okay, now in this cube, how many faces are there? Totally there are 6 faces. For in any cube there will be 6 faces. Okay, now area of all these 6 faces will be, area of 6 faces is equal to 6 into L into L, that is 6L square is the area of all the faces. Now coming to hemisphere, what is the area of the what is the surface area of the hemisphere? It is given by 4 pi r square by 2. Okay, 4 pi r square is the surface area of a sphere. Half of that is gives area of curved surface area of hemisphere. Okay, so here 2 ones are 2, 2 twos are 4. So 2 pi r square is the area of hemisphere, curved surface area of the hemisphere. So 2 pi. So what is r? R it is L by 2. Okay, because r is the diameter of the sphere, therefore half of that will be L by 2. Now coming to circle. Now there is a common plane for circle and hemisphere, that is circle. Okay, so that circle is here on the top of the solid here. So what is the area of that circle? It is pi r square. Okay, so here area is pi r square. Now pi, what is r? R is L by 2, half of diameter. Okay, L is the diameter of the sphere, also L is the length of the side of the cube. So pi r square is pi L by 2 the whole square. Okay, now what is the total area? Total area of the cube, total area of the given solid will be area of the 6 faces of the cube, that is, okay, area of 6 faces of cube plus area of curved surface area of hemisphere minus the area of the circle. This area is common to both hemisphere and cube. Okay, this is common to both of them. So area of 6 faces of the cube we got as 6L square. Now plus area of the curved surface of hemisphere is 2 pi L by 2 the whole square minus area of the circle is pi L by 2 the whole square. Now I can take L square common here. So L square, so remaining is 6 plus 2 pi. So here 1 by 4 will be left minus pi. So here also 1 by 4 is left. So now L square. Now take the LCM. So 6 means it is 6 by 1. LCM of 1 and 4 is 4. So in the first term I'll get 6 into 4 minus 2 pi, sorry, plus 2 pi minus here pi. Now this is equal to L square. Now 6 4s are 24. 2 pi minus pi is pi only I'll get. So L square into 24 plus pi by 4, or this I can simplify and write as 1 by 4 into L square into 24 plus pi. So this is the total area of the given solid, total surface area. Okay, exercise 15.1 question number 6. A medical capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. The length of the entire capsule is 14 mm and the diameter of the capsule is 15 mm. Find its surface area. So the capsule is like this. So on two sides there is a hemisphere, and in between there is a cylinder like this. Okay, now given the diameter is 5 mm and the total length is 14 mm. So since the diameter is 5 mm, what is the radius? Radius will be half of that, that is 2.5 mm. This is 2.5 mm, and here the radius also will be 2.5 mm. So what is this length? So this length is total length 14 mm minus 2.5 minus 2.5. So that is 14 minus 2.5 minus 2.5 is 5. 14 minus 5 is 9 mm. So this length is 9 mm. Now what is the area of this curved surface area of this hemisphere? It is 4 pi r square by 2. 4 pi r square is the surface area of sphere. Half of that is gives curved surface area of sphere, hemisphere. Similarly here also 4 pi r square is the area, curved surface area of the sphere. Half of that will give curved surface area of the hemisphere. And what is this curved surface area of this cylinder? It is given by 2 pi r into h, where r is the radius and height is nothing but 9 mm. Okay, usually the curved surface area of cylinder is given by 2 pi r h, where h is the height of the cylinder, but here the cylinder is placed horizontally. Okay, which is equal, and h is equal to 9 here. Okay, now total area is equal to 4 pi r square, area of first sphere, plus area of cylinder, that is 2 pi r h, plus area of the second hemisphere, 4 pi r square by 2. So here 2 will get cancelled, 2 1s are 2, 2 2s are 4, here also 2 1s are 2, 2 2s are 4. So in among this, what can I take common? Can you check? So 2 pi r I can take common, so I am left with r plus h plus r. So 2 pi r into 2r plus h I will get. Now substitute the values of pi r and h here. So 2 pi is 22 by 7, r is 2.5. So here into 2 into 2.5 plus h is 9 millimeter. So here 2 into 22 by 7 into 2.5. So 2.5 into 2 is 5. Okay, double of 2.5 is 5. So 5 plus 9 is 14. So into 14 I'll get. So 7 1s are 7 2s are 14. Now 2 into 22 into, now 2.5 into 2, double of 2.5 is 5. Okay, now 2 into 22, double of 22 is 44. 22 into 2 is 44 into 5. 5 4s are 20. 5 4s are 20, 21, 22. So 220 millimeter square is the total area of capsule. And that completes this problem. Exercise 15.1, question number 7. A tent is in the shape of a cylinder surmounted by a conical top. If the height and the diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meters, find the area of the canvas used for making the tent. Also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. Note that the base of the tent will not be covered with canvas. So here there's a tent. It is such that the bottom portion is a cylinder and the top portion is a cone, this way. And given that the diameter of the cylinder, height and diameter of the cylinder are 2.1, that is height is 2.1 meter and diameter is 4 meter, and the slant height of the conical top is 2.8, that is this side, this is slant height 2.8 meter. Okay, now find the area and the cost of the cloth used for the tent. Okay, now what is the area of the curved surface area of the cone? What is this given by? Curved surface area of the cone is given by pi r L. Okay, so here pi r L is the curved surface area of this cone, and what is the curved surface area of this cylinder? It is given by 2 pi r into h. Okay, therefore total area is equal to curved surface area of cone plus curved surface area of cylinder. Okay, so curved surface area of cone is given by pi r L, and curved surface area of cylinder is given by 2 pi r h. Now substitute all the values. Pi r, what is the radius? Radius of the cone is also equal to the radius of the cylinder. So diameter of the cone is 4. Therefore radius will be half of that. That is 4 by 2. Okay. So r is 2. 4 by 2 is 2. Then L, slant height is 2.8. 4 into 2 into 2.8 plus, so 2 pi into here r. What is r? R is 2. And what is the height of the cylinder? It is 2.1. So what all can I take common? I can take pi common, and I can take 2 also common. So 2 pi I'll take common, and I'll be left with 2.8 plus 2 into 2.1. Okay, 2.1 into 2 is 2 1s are 2, 2 2s are 4, 4.2. 4.2 plus 2.8 is 8, 9, 10, 4, 5, 6, 7. Okay, so 2 pi into 7 I am getting. So this is 2 into pi is 22 by 7 into 7. 7 will get cancelled. I am getting 44 square meters, or you can write as 44 meter square. Both are correct. Okay. Now the cost of the find the cost of the canvas of the tent at the rate of 500 meters, rupees 500 per meter. Okay. So for 1 meter square of canvas, okay, it will cost 500 rupees. Okay, therefore for 44 meter square, what is the cost? It is very simple, just cross multiplication. 44 into 500 by 1. So 4 5s are 20, 4 5s are 20, 21, 22, 220 and 00. So this many rupees, 22,000. So this is equal to rupees 22,000 is the answer. Exercise 15.1, question number 8. From a solid cylinder whose height is 2.4 centimeter and diameter 1.4 centimeter. A conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. So there is a cylinder and the diameter of the cylinder is 1.4 centimeter and the height of the cylinder is 2.4 centimeter, and one conical, okay, what is that, a conical cavity of the same height is made, okay, on this one, okay, same height and same diameter. That means like this, one conical cavity is made like this, and the height of the cone is same as the height of the cylinder, and the diameter of the cone is same as the diameter of the cylinder. Okay, now I should find the surface area of the remaining solid up to the nearest centimeter square. So here I'll draw one perpendicular line from the vertex to the top of the cylinder, okay, and let the slant height of cone be L. Okay, now what is the area of the circle below here, area of the base of the solid here? So the base of the solid is a circle, so area of that circle is given by pi r square. Okay, now what is the curved surface area of the cylinder given by? Curved surface area of the cylinder is given by 2 pi r into h, okay, where h is 2.4 centimeter. Now what is the curved surface area of the cone? Curved surface area of this cone is given by pi r into L. Okay, now what is L? L is not known. So since the diameter of the cylinder is same as the diameter of the cone, what will be the radius? Radius will be half of diameter, that is 1.5 by 2. What is this? 0.7. So the radius is 0.7. Okay, radius is 0.7, and this also is 2.4. Height is 2.4. Now what is L? Now I'll mark this as A, B and C. So ABC is a right angle triangle. Now applying Pythagoras theorem here, I'll get BC square. BC square is equal to AB square plus AC square. So AB is 0.7 the whole square plus AC is 2.4 the whole square. Now 0.7 the whole square is 7 into 7 is 49. So decimal is there, therefore I'll get like this 0.49. Okay, then 2.4 into 2.4. So 2.4 into 2.4. 4 4s are 16, 4 2s are 8, 9, plus 2 4s are 8, 2 2s are 4. So 6, 8 8 16 17, carry 1 5 76. Okay, so 2.4 into 2.4, therefore I'll get 5.76. So when we add these two, 9 6 15 carry 1, 4 plus 1 5 5 10 12 carry 1, then 6.25. So BC square is 6.25. Now what is it? Therefore BC is equal to plus or minus square root of 6.25. Now what is the square root of 6.25? So now 2 2s are 4. 6 minus 4 is 2. Now I'll add this 2 again here. 2 plus this 2, I'll get 4. Now I should take this 2 and 5 below. So there's a decimal point. I'll keep that decimal point here. Take these two digits, 2 and 5. Now 45 into 5, 5 5 are 25, 5 4 are 20, 28, 21, 22, so 0. So square root of 6.25 is 2.5. So plus or minus 2.5 I'll get, but BC is equal to, I'll take 2.5. I'll discard negative value because here the dimension cannot be negative. Okay, so L is 2.5, BC is nothing but L. Now what is the total surface area? Total surface area is given by area of circle, that is the bottom of the cylinder, then curved surface area of cylinder plus curved surface area of cone. Okay, I should add all this. Now area of the circle is given by pi r square plus area of cylinder is given by 2 pi r into h plus area of cone is given by pi r into L. Now what all things I can take common? I can take common pi, I can take r as common, pi and 1 r. Okay, so pi r will take common. In the first term only r will be left, in the second term 2 into h is left, and in third term only L is left. So now substitute, pi is 22 by 7, r radius is 0.7. So now into r is 0.7 plus 2 into h is 2.4 plus L is the slant height I got as 2.5. Okay, now simplify, 2.4 into 2, the 2 4s are 8, 2 2s are 4, 4.8 plus 2.5 plus 0.7, how much? So 5 3s are 15, 16, 17, 18, 19, 20, then 4 5 6 7 4 5 6 7 8, 8.0 I'm getting. So 22 by 7 into 0.7 into 8.0 means 8 only. Okay, now this 7 ones are 7, 7 ones are 7, so since decimal is there I'll get 0.1. Now this is equal to 22 into 0.1 into 8. So 22 into 0.1 is 2.2. Okay, now 2.2 into 8, 8 2s are 16, 8 2s are 16 plus 1 17, so 176, 1, that means 17.6 total surface area is 17.6 centimeters square. If you check the answer, in the answer it has been given as 18 centimeters square. So actually in the question what they have asked, find the total surface area of the remaining solid to the nearest centimeter square. So approximate value they are asking. So 17.6 centimeters I can approximate to 18 centimeters square. So this is exact answer, this is approximated answer. So you can keep this answer only. In textbook the second answer they have given 18 centimeters square they have given, but you can keep 17.6 centimeters square as the answer itself, because that is the exact answer. Okay, and that completes this problem. Exercise 15.1, question number 9. A wooden article was made by scooping out a hemisphere from each of its solid cylinder as shown in figure 15.11. If the height of the cylinder is 10 cm and its base is of radius 3.5 cm, find the total surface area of the article. So this is a very simple problem. Total surface area I should find. So what is the area of the curved surface area of the cylinder? So it is given by 2 pi r into h, where h is 10 centimeter and r is 3.5 centimeter. Radius of the cylinder is 3.5 centimeter. Okay, now what is the curved surface area of this hemisphere? So it is given by 4 pi r square is the curved surface area of a sphere. So half of that will be the curved surface area of hemisphere. Similarly, what is the curved surface area of this hemisphere? It is 4 pi r square by 2. Very simple. So when I add all this area, I'll get the total area of the curved, total area of the surface. Okay, now total area is equal to area of first hemisphere, okay, plus curved surface area of cylinder plus area of the bottom hemisphere. Okay, so area of the first hemisphere, that is the top hemisphere, is now here 4 pi r square by 2. Then curved surface area of cylinder is 2 pi r into h, plus area of the bottom hemisphere is 4 pi r square by 2. So here 2 ones are 2, 2 twos are 4, 2 ones are 2, 2 twos are 4. So what all the common things I can take now? I can take pi common, and also I can take 2 common. So 2 pi. So also 1 r I can take common. Okay, so 2 pi r. And now what is left? 1 r is common in the first, 1 r is left in the first term. In the second term, r I have taken common. Okay, h is left, and in this last term another r is left. Okay, now this is equal to 2 pi r. So r plus r is 2r plus h. So this is equal to 2. Now substitute the values of pi and r. 22, pi is 22 by 7. R, what is the radius? It is 3.5 centimeter. Then here 3.2 into 3.5 plus what is the height? Height is 10. So this is equal to 2 into 22. 2 into 22 by 7 into 3.5. Now 2 into 3.5, twice of 3.5 is 7. 7 plus 10. Okay, so 17 I'll get there. So 2 into 22 by 7 into 3.5 into 17. Now 7 ones are 1, 7 5s are 35. So since here 3.5 is there, I'll get 0.5. 7 5s are 35. Okay, now what is 2 into 0.5? 2 into 0.5 is 1. 1.0, I'll get decimal. So 2 into 0.5 is 1. So 1 into 22 into 17. So now 17 into 22. 7 2 is 14. 2 under 2, 1, 2 under 2, plus 1 3. So 34, 34, 4, 4, 5, 6, 7, 3, 374. So 374. So all the units were in centimeter. So I'll get the area as centimeter square. So I think you know what the unit of area. Unit of area is in centimeter square, meter square, that way. Okay, and that completes this problem and this exercise. The next topic is volume of combination of solids. Okay, let us recall some basics of volumes of some solids. Okay, now consider one cube. Okay, cube is given like this. So in a cube all the sides are equal. Okay, so this is actually invisible edge. Okay, all the sides are equal in a cube. Okay, now what is the base area of the base of the cube? Okay, this is the area of the base of the cube is given by a into a, side into side gives the area of the base. Now for the area, if I multiply the height also is a here. Okay, so if I multiply the height also, I'll get the volume. So volume of a cube is given by a into a, where a is the dimension of the sides. Now similarly cuboid, when it comes to cuboid is like this. Here this is the invisible edge. Here the dimension are different, like if the breadth is b and this is the length and this is the height. Okay, now what is the area of the base? Area of the base is given by side into side, that is here length into breadth. Length into breadth gives the area of the base. Now for the area of the base, if I multiply the height also, that gives volume. Okay, so for cuboid the volume is length into breadth into height. Now similarly, what is the volume of cylinder? So cylinder is like this. This is the invisible edge, and if h is the height and if r is the radius. Okay, so here also the radius will be r. What is the area of the base? Area of the base is area of the circle. Okay, so here pi r square is the area of the base. Now for the area, if I multiply the height also, it gives the volume. So the volume of a cylinder is pi r square into h. And what about cone? So in a cone, let r be the radius and let L be the slant height. So this is the slant height. Okay, so here what is the area of the base? So base is nothing but a circle, so area of the circle is given by pi r square. Now for pi r square, if I multiply length and divide by 3, that gives the volume of cone. Okay, sorry, it is not L, it is h. Okay, pi r square into h by 3. Okay, if h is the height of the cone, so this is the height of the cone, then the volume of the cone is given by pi r square into h by 3, or 1 by 3 times of pi r square into h. Okay, now what is the volume of sphere? If r is the radius, what is the volume of sphere? So volume of sphere is given by pi r cube into 4 by 3. So 4 by 3 times of pi r cube gives the volume of the sphere. Now we know all the formulas of the volume of some basic solids. Let us see what is there in the textbook. in the textbook you can find some simple worked examples. For example, now what is the volume of this solid here? So this is made up of two parts. One is a cuboid which is at the bottom, and another is half of a cylinder which is at the top. Now total volume will be volume of this cuboid plus volume of this half of this cylinder. Okay, you can see the required volume will be volume of cuboid plus half the volume of the cylinder. Now in this problem you can see there is a cylinder and one hemisphere is cut out of that. Okay, now what is the remaining volume here? So volume of this cylinder minus volume of this hemisphere gives the volume of this object. Okay, you can see here whatever volume of this cylinder minus volume of the hemisphere gives the answer. All these are very simple problems, all are self-explanatory, just go through it. I'll be solving exercise problems. Exercise 15.2, question number 1. A solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter and the height of the cone is equal to its radius. Find the volume of the solid in terms of pi. So this solid is made up of a hemisphere and a cone, and the radius is equal to 1 centimeter. Okay, right, it's 1 centimeter. So here also it is 1 centimeter, and the height of the cone is equal to the radius. That means height of the cone also is equal to 1 centimeter. Okay, now find the volume of the solid in terms of pi. Now total, what is the volume of hemisphere? So volume of a sphere is given by 4 by 3 pi r cube. Okay, and half of that gives volume of hemisphere. Okay, and what is the volume of cone? Volume of cone is one third of pi r square into h. Okay, where h is the height of the cone. Now total volume is equal to volume of cone plus volume of hemisphere. Okay, volume of cone is 1/3 of pi r square into h plus volume of cone is half of volume of sphere. Volume of sphere is given by pi r cube by 4 by 3 pi r cube. Okay, or pi r 3 cube by 3. Okay, now what all I can take common here? I can take 1 by 3 common, I can take pi common, I can take r square common. So what I'm left with? I'm left with h plus, and here 1 by 2 is left, and here 1 by 2 into 4 r will be there. Okay, now this is equal to 1 by 3 pi r square h. Now 2 1s are 2, 2 2s are 4, so h plus 2r. Now substitute all the values of h and r. So 1 by 3 pi r is 1 centimeter, so 1 square into h also is 1 centimeter plus 2 into r is 1. So this is equal to 1 by 3 pi, 1 square is 1 only. Okay, into now 1 plus 2 into 1, 2 into 1 is 2 only, so 1 plus 2 is 3, so 3 will get cancelled, answer is pi. So if radius of the hemisphere is equal to the height of the cone, then objects like this will have area pi square units. Here it is in centimeter, that's why it is pi centimeter square. Okay, sorry, it's a centimeter cube. Okay, volume is always in centimeter cube or in meter cube, like that. Okay, if length is in centimeter, volume will be in centimeter cube. If length is in meter, volume will be in meter cube, that way. Okay, exercise 15.2, question number 2. Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height of 2 cm, find the volume of the air content in the model that Rachel made. Assume that the outer and inner dimensions of the model to be nearly same. So here there is a model. It says that the middle part is a cylinder and top part is a cone and bottom part also is a cone. So in this way that model has been done, and given that the diameter is 3 cm. Okay, this is 3 cm and total height of the model is 12 cm. 12 cm and height of each cone is 2 cm. 2 cm. Now what is the height of this cylinder here? This will be 12 minus 2 minus 2. So 12 minus 2 minus 2 is 8 cm. 8 cm is the height of the cylinder. Now what is the total volume of the model? So now what is the volume of this topmost cone? It is 1/3 of pi r square into h, and volume of this bottom cone also will be equal to 1/3 of pi r square into h, and the volume of this cylinder is given by pi r square into h. So here h is 8 cm. In the cone h is equal to, okay, in the cone h is equal to 2, and here h is equal to 8, and here h is equal to 2 again. Okay, now total volume is equal to volume of cone, that is top cone, then volume of cylinder plus volume of cone, that is the bottom. So now substitute. Volume of cone is 1/3 pi r square h plus volume of cylinder is pi r square into h plus volume of cone, volume of cone in the bottom is 1/3 pi r square h. Now in all the three, what all can I take common? I can take pi common. Okay, and I can take r square also common. Okay, so pi r square I'll take common. I'm left with, in the first one, h/3. So here in the cone h is 2/3 plus here in the second that is cylinder h is 8. Okay, so here again it is h is 2 and 3. Okay, 1/3 into h is left. So pi, so r is, what is r? What is the diameter given? Diameter is 3 cm, right? So 3 cm. So r is 3/2 the whole square. So into, now what is the LCM of 3, 1 and 3? So 8 means it is 8/1. So LCM now is 3. So 2 plus, now here to make 1 equal to 3 I should multiply by 3, so 8 into 3, 8 into 3 plus 2 as it is here, so this is equal to pi 3 by 2 the whole square into 3 in the bottom. So here 2 plus 3 8 are 24, 24 plus 2 plus 2, 24, 28 I will get, okay, 28. Now substitute the value of pi also. Pi is 22 by 7 into 3 by 2 the whole square is 3 by 2 into 3 by 2 into 28 by 3. Now 7 1s are 7, 7 4s are 28. This 3 will get cancelled with this 3. Now 2 1s are 2, 2 2s are 4. Now again this 2 will get cancelled with this 2. I am left with 22 into 3, 22 into 3. So this is equal to 66. 66 means 66 centimeter cube. Okay, since the dimension is given in centimeter, the volume will be in centimeter cube. Exercise 15.2, question number 3. A gulab jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with length 5 cm and diameter 2.8 cm. So gulab jamun, it's in the shape of a cylinder and two hemispheres like this, and given the length of the gulab jamun is 5 cm and diameter is 2.8 cm. So since the diameter is 2.8 cm, what will be the radius? Radius will be equal to half of diameter, that is 1.4. So this is 1.4. Here also the radius will be equal to 1.4 centimeter. Now what is the width of this cylinder? Here like this, so that will be equal to 5 centimeter. 5 centimeter minus 1.4 minus 1.4, so that is 5 minus 2.8, so this is equal to 2.2. so the length of this cylinder is 2.2. okay, now what is the volume of this hemisphere? So volume of sphere is given by 4 by 3 pi r cube. Okay, half of that will be volume of hemisphere. Now what is the volume of this hemisphere? So here also volume of sphere is given by 4 by 3 pi r cube. So half of that will be the volume of the sphere, volume of the hemisphere. Now what is the volume of this cylinder? This volume of cylinder is given by pi r square into h. Now here h is 2.2. okay, h is 2.2. now total volume of jamun, volume of gulab jamun is given by volume of hemisphere plus volume of cylinder plus volume of the other hemisphere. So volume of first hemisphere is 1 by 2 into 4 by 3 pi r cube plus volume of cylinder is pi r square into h plus volume of another hemisphere is 1 by 2 into 4 by 3 pi r cube. Now in all the three, this is 4 by 3. So in all the three, what all the common factors that I can take? I can take pi common factor, and also I can take r square as common factor. So pi, I'll take r square, I'll take common factor. Now 2 1s are 2, 2 2s are 4. Here also 2 1s are 2, 2 2s are 4. Now remaining I am left with, in the first term 2 into r is left, and in the second term pi r square taken common, h is left, and in the third term 2 is there, pi r square I have taken common, so another r will be 2. Okay, 2 r will be left. Okay, and also 3, sorry, 3 also is there here. Okay, now this is pi r square. Now take the LCM. Okay, now LCM of 3, 1 and 3 is 3, so I'll get 2r plus 3h plus 2r. Okay, now substitute the values of pi and r. So pi is 22 by 7, r is 1.4 the whole square. Now here 2r plus 2r I'll get 4r plus 3h, okay, by 3. So now this is equal to 22 by 7 into 1.4 the whole square into what is r is 1.4, so 4 into 1.4 plus 3 into h is 2.2, 3 into 2.2. So now this is equal to 22 by 7 into 1.4 the whole square is 1.4 into 1.4 into, now 4 into 1.4 I'll get 5.6 plus 3 into 2.2 I'll get 6.6 by 3. So this is equal to 22 by 7. Now here also 7 1s are 7, 7 2s are 14, so I'll get 0.2. So I'll get 22 into 0.2 into 1.4. Now 5.6 plus 6.6, 5.6 plus 6.6 I'll get 12.2. So 12.2 by 3. So this is the volume of 1 gulab jamun. Okay, volume of 1 gulab jamun. Therefore volume of 24 jamuns will be volume of 45 jamuns will be 45 into this, so 45 into 22 into 0.2 into 1.4 into 12.2 by 3. So here 3 1s are 3, so it is 45. 3 1s are 3, 3 1s are 3, 3 5s are 15. So it is 15 into 22 into 0.2 into 1.4 into 12.2. Now it is given that one gulab jamun, it contains 30% of syrup. Okay, that means what is the each gulab jamun, because of each gulab jamun there is 30% of syrup. Okay, therefore for 45 gulab jamuns what is the syrup, that's the question. Therefore for 45 jamuns, okay, the syrup will be 30% of this volume, that is 30 by 100. So this is syrup. So because of one gulab jamun there is 30% of syrup. Therefore for 45 gulab jamun the syrup will be 30 by 100 into 15 into 22 into 0.2 into 1.4 into 12.2. So this turns out to be 338.184. So this multiplication and division is left to you. It's left as an exercise to you. Multiply and check it out. It comes out to be 338.184 centimeter cube. Since this is a volume, the unit will be in centimeter cube. So the dimension all are in centimeter. That's why the volume will be in centimeter cube. So this is approximately equal to 338 centimeter cube. So in the textbook the answer is given as 338 centimeter cube. You can leave this also as answer. It's perfectly right. And that completes this question. Exercise 15.2, question number 4. A pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens. The dimension of the cuboid are 15 centimeter by 10 centimeter by 3.5 centimeter. The radius of each of the depression is 0.5 centimeter and the depth is 1.4 centimeter. Find the volume of the wood in the entire stand. So the figure is given. Now what is the volume of cone? Volume of cone is given by 1/3 of pi r square into h. Now it is given that what is the radius of the cone? The radius of each of the depression is 0.5, that is r is 0.5 into 0.5 into what is h? H is nothing but depth here, 1.4. okay, it's 1.4. so substitute 1/3 into 22/7 into 0.5 into 0.5 into 1.4. Now volume of 4 cones. So the above we got volume of 1 cone, therefore volume of 4 cones will be 4 into 1/3 into 22/7 into 0.5 into 0.5 into 1.4. Now 7 1s are 7, 7 2s are 14, so 0.2 I'll get here. So I'm left with 4/3 into 22 into 0.5 into 0.5 into 0.2. Now what is the volume of cuboid? Volume of cuboid, given that the length is length, breadth and height is 15 centimeter and 10 centimeter and 3.5 centimeter. Therefore volume of cuboid will be 15 into 10 into 3.5. okay, therefore the volume of stand, okay, this I'll mark as 1, this I'll mark as 2. So volume of stand is nothing but 2 minus 1. So what is 2? 15 into 10 into 3.5. 1 is 4/3 into 22 into 0.5 into 0.5 into 0.2. Now this is equal to 525. 15 into 10 into 3.5, I'll get 525, and the next term I'll get as 1.4666. okay, 1.4666 4666, it's recurring actually. So if you subtract these two, you get 523.533. So here actually 3 you will get recurring, so you can approximate to 523.53. This many centimeter cube is the volume of the stand. Exercise 15.2, question number 5. A vessel is in the form of an inverted cone. Its height is 8 centimeter and the radius of its top, which is open, is 5 centimeter. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots. So the vessel is in the form of inverted cone like this, and the height of the cone, okay, is 8 centimeter. So this is 8 centimeter, okay, and what is the radius? Radius is 5 centimeter. So this length is 5 centimeter, okay. Now this is fully filled with water and some spears are dropped onto this. When spears are dropped, water will start spilling out of this vessel, right? So now what is the spear that is dropped? It has okay, this spear has radius 0.5 centimeter. So such spears are dropped one by one, and 1/4 of water comes out of the vessel. So how many spears were dropped? That's the question. Now what is the volume of cone is given by? Volume of the cone is given by 1/3 of pi r square into h. Here r is 2.5, half of diameter, that is diameter is 5, so half of 5 is 2.5, and h is 8 centimeter. And what is the volume of sphere? Volume of sphere is given by 4/3 pi r cube, okay. 4/3 pi r cube is the volume of sphere. Now let us find what is the volume of cone. It is given by 1/3 pi r square into h. So this is 1/3 into pi is 22/7 into r. R is 5/2. Half of 5 is, okay, I'll keep it as 5/2 only. 5/2 the whole square into h is 8, okay. So now what is 1/4? Sorry, how much water is coming out? 1/4 of the water, yeah, okay. 1/4 the volume of cone is equal to 1/4 into, okay, 1/4 into 1/3 into 22/7 into 5/2 into 5/2 into 8. So 1/4 volume of cone is this much. Now what is the volume of sphere? Is given by 4/3 pi r cube. So this is equal to 4/3 into what is pi, 22/7 into r. What is the radius? Radius is 0.5. So 0.5 into 0.5 into 0.5. Now this is, I'll take as 1, this I'll take as 2. Now if I divide 1/2, I'll get the number of spheres, okay. So 1 divided by 2 gives, so what is 1? 1 is 1/4 into 1/3 into 22/7 into 5 by 2 into 5 by 2 into 8 divided by 4 by 3 into 22 by 7 into 0.5 into 0.5 into 0.5. So now 22 by 7 will get cancelled. Now is there anything that I can cancel? Now 4 ones are 4, 4 twos are 8 here. So now in the numerator I will be left with 1 by 3 into 5 by 2 into 5 by 2 into 2. The denominator I am left with 4 by 3 into 0.5 into 0.5 into 0.5. So this is equal to, now in the numerator 2 by 2 means it is 2 by 1, and even in the denominator 0.5 means it is 0.5 by 1, 0.5 by 1, 0.5 by 1. Now I will bring all the denominator to the numerator. So first I will write numerator as it is 1 by 3 into 5 by 2 into 5 by 2 into 2 by 1. Now I will bring the denominator into the numerator. So when I bring 4 by 3 to the numerator, it becomes 3 by 4. Similarly 0.5 by 1 becomes 1 by 0.5, and here also the other one also it becomes 1 by 0.5 into 1 by 0.5. Okay, now I can cancel this 3 and this 3. I can cancel this 2 and this 2. Now 5 ones are 5, 5 ones are 5, that is 0.1 I will get. Again 5 ones are 5, 5 ones are 5, 0.1. Okay, now I am left with, in the numerator nothing is left. So nothing is there means it is 1. Okay, or 1 into 1 into 1, there are 4 ones. Okay, then in the denominator 2 is left, again 1 is left, again 0.1 into 0.1 into 0.5. So in the numerator now 1 into 1 into 1 is 1 only, and in the denominator, okay, 2 into 1 into 0.1 into 0.1 into 0.5. So here in the numerator 2 into 0.1 into 0.1 into 0.5, I will get totally 100. You can check it out. Sorry, I will get 1 by 0.01 I will get. Okay, that I will leave it to you. Now 1 by 0.01 is, this is nothing but equal to 100. If you divide 1 by 0.01, you will get 100. So this is the number of sphere that were dropped into the vessel, so that 1/4 of the water spilt out of the vessel. In the denominator it is a 0.01, so you can shift the decimal point. So 1 by 0.01 is there. Now like this you can shift the decimal point. So if you shift the decimal point by 2 places, okay, you should put 2 zeros in the numerator. So when we shift the decimal point 2 places in the denominator, it becomes 1.0. Okay, or 100 by 1. 100 by 1 is 100 only. Exercise 15.2, question number 6. A solid iron pole consists of a cylinder of height 220 cm and base diameter 24 cm, which is surmounted by another cylinder of height 60 cm and radius 8 cm. Find the mass of the pole, given that 1 cm cube of iron has approximately 8 gram mass. Use pi is equal to 3.14. So the figure is like this. There are two cylinders. First cylinder, the one which is in the base, has height 220 cm and diameter 24, and the top cylinder has height 60 centimeter and diameter is 16. So given the radius of the top cylinder is 8 centimeter, therefore diameter is 16. Now what is the volume of the top cylinder? So it is given by pi r square into h. So here r is equal to 16 by 2, that is 8. R is equal to 8 centimeter and h is equal to 60 centimeter. And what is the volume of the second cylinder? It is pi r square h. So here radius is 24 by 2, that is 12. And what is the height? Height is 220. Okay. Now what is the total volume? Total volume is equal to volume of these two. Okay, so sum of volume of these two cylinders. Okay, this is equal to pi r square h plus pi r square into h. Okay, I'll take h1 and h2. So pi I can take common, and this is r1 and r2 I'll take. So pi r1 square h1 plus r2 square h2. So now here it is pi r1 is 8, so 8 square, h1 is 60 and r2 is 12 square, h2 is 220. Okay, this is the total volume. And what they have given, what is the mass of the pole? Given that 1 centimeter cube of iron has approximately 8 gram mass. Okay, 1 centimeter cube of volume of iron has 8 gram of mass. Okay, therefore pi into 8 square into 60 plus 12 square into 220. Therefore this much centimeter cube. Okay, so total volume is this many centimeter cube. So this much volume has how many mass? How much mass? That's the question. So just cross multiply. So this is unitary method. We can cross multiply and get the answer. So the answer is pi 8 square into 60 plus 12 square into 220 into 8 divided by 1. Okay, this into this divided by 1. That's it. That's the answer. So now pi they are told to take as 3.14. So into now 8 8 is 64 into 60 plus 12 into 12 144. 12 into 12 is 144 into 220 into 8 divided by 1 means I'll get this much only. Now what is this one? This is actually equal to 892262.4 grams. Okay, so this pole has weight 892262.4 grams, or if I convert into kgs, I should divide by 2. So divide by 1000, divide by 1000. So 892262.4, if I divide by 100, gram will become kg. So this is equal to 892.2624 kg. So the mass of this pole is 892.2624 2624 kg. Here 1 kg is equal to 1000 grams. Okay, that's why I divided by 1000 to get the answer. Otherwise you can leave the answer here also. This answer also is perfectly right. You will get full marks. 892262.4 grams. Even that is also perfectly correct. Exercise 15.2, question number 7. A solid consisting of a right circular cone of height 120 cm and radius 60 cm standing on a hemisphere of radius 60 cm is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of the water left in the cylinder if the radius of the cylinder is 60 cm and its height is 120 cm. So here the solid is consisting of hemisphere and a cone, and it is such that the cone is above the hemisphere. Okay, the figure I have drawn there, and that is placed inside a cylinder whose radius is 160 cm and height is 180 cm, and the radius of the hemisphere is also 60 cm, and the radius of cone also is 60 cm, and the height of the cone is 60 cm. Now what is the volume of the cone given by? Volume of the cone is given by 4 pi r cube. 4 pi r cube by 3 gives the volume of sphere. Half of that will be the volume of hemisphere. And what is the volume of cone? Volume of cone is given by 1/3 of pi r square into h. Okay, where r is the radius and h is the height of the cone. Now I should find the volume of the water. Okay, this volume I should find. Okay, so now, and what is the volume of the cylinder given by? Volume of the cylinder is given by pi r square into h, where r is the radius of the cylinder and h is the height of the cylinder. Here h is 180, and for the cone h is 120. Okay, and r is common for all the three. Okay, now what is the volume of water left? Volume of water will be equal to volume of cylinder minus volume of sphere. Okay, volume of cylinder minus volume of sphere minus volume of cone gives the volume of water. So what is the volume of cylinder? It is given by pi r square into h. Volume of sphere is given by, so 1/2 into 4 pi r cube by 3, and volume of cone is given by 1/3 of pi r square h. So here h is 120, here h is 180. Okay, this I'll take as h1, this I'll take as h2. Okay, now substitute the values of r and h. Pi, so r is 60 square, h is 180 minus 1/2. So here 2 will get cancelled, 2 1s are 2, 2 2s are 4, so 2/3. So 2/3 into pi, r is 60, so 60 cube minus 1/3 pi. So here also r is 60 into 60 square. Here h is 120. Now can I take anything common here? I can take pi common here, and also I can take 60 square common. So I am left with, so pi into 60 square I will take common. In the first term I will be left with 180. Okay, minus here 2/3 into, so since the 60 square I am taking common, here one more 60 will be left, 2 by 3 into 60 minus here 1 by 3. 1 by 3 here, pi 60 square I have taken common, so I will be left with 120. So here 3 ones are 3, 3 twos are 6, here 3 ones are 3, 3 fours are 12, 0. So I am left with pi into 60 square into 180 minus 2 twos are 4 minus 40 minus here 1 into 40 is 40. Now here it is pi into 60 into 60, 6 6 are 36, 3 6, so 00 will come because 60 into 60, 2 zeros will come there, then into, now here 40, sorry, 180 minus 40 minus 40 is minus 80. So I'll get pi into 3600 into 100. 180 minus 80 is 100. So now pi into 3600. So when I multiply by 100, another 2 zeros will get added. So this is now 36 into 22 by 7. So 36 into 22 by 7, you will get 1131,428.57 centimeter cube. Okay, this is the answer. 1131,428.57 centimeter cube. But 1 centimeter is equal to 1 by 100 meter. Okay, now I can write as 1131,428.57 into, so 1 centimeter means 1 by 100 into 1 by 100 into 1 by 100, it becomes meter cube. Now 1 by 100 into 1 by 100 into 1 by 100 is how much? 1 by 100 into 1 by 100 into 1 by 100 is equal to 1 divided by 1 followed by 6 zeros, 1 2 3 4 5 6. So now here decimal point will shift, I will get 1.3142 meter cube approximately. Okay, volume of water is 1.3142 meter cube. So you can leave the answer here also, even this is also correct, or you can leave the answer here also, this is also correct. To be more specific, we can give this answer, or if we want in meter only, we can give this answer. All these three answers are correct, you will get full marks. Exercise 15.2, question number 8. A spherical glass vessel has a cylindrical neck 8 cm long, 2 cm in diameter. The diameter of the spherical part is 8.5 cm. By measuring the amount of water it holds, a kid finds its volume to be 345 cm cube. Check whether she is correct, taking the above as the inside measurement, and pi is equal to 3.14. So the figure is like this. This is the vessel. So we should find the volume, and they said some kid is has measured the volume, and according to the kid 345 centimeter cube is the volume. So we should check the volume and we should compare with that volume. If it matches, then it is correct, or it is no. Now what is the volume of this sphere here? So the diameter of the sphere is 8.5 centimeters. So what is the volume? What is the formula of volume of sphere? So 4 pi r cube by 3 is the volume of sphere. Okay, where now here r is equal to 8.5 by 2, because 8.5 is the diameter. And now what is the volume of this cylinder here? This volume is given by 4 pi r square. sorry, pi r square into h. Okay, so what is r here? R is half of the diameter of the neck is 2 centimeter. Okay, so 2 centimeter by half of the half of diameter is radius, so 2 by 2 is equal to 1. And what is h? Height of the neck is 8 centimeter. Okay, so volume is equal to volume of neck plus volume of sphere. So what is the volume of neck? That is pi r square into h. Okay, I'll take okay, pi r square into h. I'll take this as r1 plus volume of sphere, that is 4 pi r. I'll take this as r2 cube by 3. So here I can take pi as common, pi I'll take common, so r1 square into h plus 4 by 3 r2 cube I'll get. So here pi, so r1 is 1 centimeter, 1 into height is 8 centimeter plus 4 by 3 into r2 cube. So r2 is nothing but the radius of the sphere. So r2 here is 8.5 by 2, that is 8.5 by 2 into 8.5 by 2 into 8.5 by 2. I can take like this. Now 2 ones are 2, 2 twos are 4, again now 2 ones are 2, 2 ones are 2. Now I will be left with pi into 1 8s are 8 plus in the numerator 8.5 into 8.5 into 8.5 divided by 3 into 2. Now this is equal to pi into 8. So 8.5 into 8.5 into 8.5 divided by 6 gives 102.354. Okay, still decimal is continuing. I'll stop here. Now this is equal to pi into then 8 plus 102.354 gives 110. Okay, 110.354. So now substitute the value of pi. Pi is 22 by 7 into 10, 110.354. So have they they've told to take the value of pi as 3.14. Okay, so I'll multiply by 3.14 into 110.354. So this gives 346.51 centimeter cube. So the measurements were in centimeter, therefore volume will be in centimeter cube. Okay, this is volume of water. So what's the question? Check whether the child is correct. So child is wrong. Child got 345 centimeter cube as the answer. Okay, the child is wrong. And that completes this problem and this exercise. The next topic in this chapter is conversion of solid from one shape to another. So now consider the example in this textbook. Now consider this cylinder which is full of water, and water is poured to another container which is cube in shape. Okay, and suppose after pouring, if the water completely fill this cube, then the volume of this cylinder will be equal to the volume of this cube. So when the water was in this cylinder, the height of the cylinder and the radius of cylinder was something, but when we pour here to this cube, the dimension of the cube may be different. It won't be same as the radius or the height. Okay, it may be different, And similarly here also there are two cylinders here. Okay, when we pour water from the first cylinder to the second cylinder, and if the second cylinder gets completely filled, you can observe that the height and radius of the first cylinder and the height and radius of the second cylinder will be different. Now in example 8 you can see a cone of height 21 centimeter and height and radius of base 6 centimeter is made up of modeling clay. A child reshapes it in the form of sphere. So cone is converted into sphere. Therefore volume of cone will be equal to volume of sphere. Find the radius of the sphere is the question. Now you can see the volume of sphere is equal to the volume of cone. Finally when we substitute all the values, we can get the radius of sphere. Now there are many worked examples. All explanation have been given. It's all very simple problems. You just go through it, you will understand by yourself. I'll be solving only the exercise problems. Exercise 15.3, question number 1. A metallic sphere of radius 4.2 is melted and recasted into the shape of a cylinder of radius 6 cm. Find the height of the cylinder. So there is a sphere of radius 4.2 cm. So this is recasted into a cylinder of radius 6 cm. So radius is 6 cm. Okay, now I should find what is the height. Now what is the volume of sphere is given by? So volume of sphere is given by 4 by 3 pi r cube, and volume of cylinder is given by volume of the area of the base pi r square. Pi r square is the area of the base of this cylinder into height gives the volume, right? Okay, here r is equal to 4.2, here r is equal to 6. Okay, now equate both, because this is recasted into sphere is recasted into cylinder, therefore volume will be equal. So 4 by 3 pi, substitute the values of r. So here it is 4.2 the whole cube is equal to, here pi r square, here it is 6, r is 6, so pi 6 square into h. So these two are equal. Now here pi and pi will get cancelled. I will be left with 4 by 3 into 4.2 into 4.2 into 4.2 is equal to 6 into 6 into h. Now 3 1s are 3, 3 1s are 3, 3 4s are 12. So I am left with 4 into 1.4 into 4.2 into 4.2. So if I cross multiply, 6 by 6 will come to the denominator. 6 into 6 will come to denominator is equal to h. Now 2 2s are 4, 2 3s are 6. Then again 2 2s are 4, 2 3s are 6. Now 3 1s are 3, 3 1s are 3, 3 4s are 12. 3 1s are 3, 3 1s are 3, 3 4s are 12. So I am left with 1.4 into 1.4 into 1.4. So 1.4 into 1.4 you will get as 2.74 is equal to h. So h is equal to 2.74 centimeter. So radius was given in centimeter. So here height will be in centimeter, 2.74 centimeter. Exercise 15.3, question number 2. Metallic sphere of radius 6 cm, 8 cm and 10 cm respectively are melted to form a single solid sphere. Find the radius of the resulting sphere. So there are three spheres. First sphere has radius 6 cm, second sphere has radius 8 cm, and third has radius equal to 10 cm. Okay, this is 6 cm, 8 centimeter, and radius is 10 centimeter. So all these are melted and made into a single sphere. Okay, now I should find the radius of this. Okay, now all this as volume. So volume of these three, okay, volume of these three spheres is given by 4 by 3 pi r 1 square, sorry, cube, 1 cube, where r1 is the radius of first sphere, plus volume of second sphere is 4 by 3 pi r2 cube, where r2 is the radius of the second sphere, plus 4 by 3 pi r cube pi r3 the whole cube, pi r3 is the radius of the third sphere. So all these are melted into and formed into a single sphere. What is the, so this the sum of all these volumes will be equal to volume of the resulting sphere. So volume of the resulting sphere is 4 by 3 pi r cube. Okay, now in the first three I can take 4 by 3 as common, 4 by 3 pi. So r1, now I am left with r1 cube plus r2 cube plus r3 cube. So this is equal to 4 by 3 pi r cube. R is the radius of the resulting sphere. Now this pi will get cancelled, 4 by 3 will get cancelled. Substitute the values of r now, r1, r2 and r3. r1 is 6, so 6 cube plus r2 is 8 cube plus r3 is 10 cube is equal to, here r cube we don't know, that's what we need to find. So now 6 6 are 36, 8 8 are 64, plus 100 into 100 is, sorry, 10 into 10 is, sorry, it's all cube, right? Sorry, 6 cube is 6 into 6 into 6, 6 into 6 into 6 is 216, you will get 216, plus 8 into 8 into 8, 8 into 8 into 8, you get 512, so 512 plus 10 cube, 10 into 10 into 10 is 1000, 1 followed by 3 zeros is equal to r cube. Then 1000 plus 512 plus 216, so 6 7 8, 1 2 5 6 7, so you get 1728 is equal to r cube. So r third root of 1728 is equal to r. So now how to find it? To find r, factor is 1278, so it's divisible by 2, divided by 2, 2 6 are 12, sorry, 2 8s are 16, 2 8s are 16, 2 1 is remaining, 2 6 are 12, 2 4s are 8. Now this is divisible by 2 again, 2 4s are 8, 2 3s are 6, 2 2s are 4, then 2 1s are 2, 2 1s are 2, 2 6 are 12, sorry, 2 2s are 4, 2 1s are 2, 2 6 are 12, then here 2 1s are 2, 0, 2 8s are 16, then again 2 5s are 10, 2 4s are 8, again it's divisible by 2, 2 2s are 4, 2 7s are 14. Now it's not divisible by 2, it is divisible by 3, 3 3s are 9, again, sorry, 3 9s are 27. Now from 3 again 3 3s are 9, 3 1s are 3. Now you can group 3 3 like this, or I can write this is equal to third root of 2 into 2 into 2 into 2 into 2 into 2 into 3 into 3 into 3 is equal to r. Okay, now I'll group like this. Since this is third root of 1728, I'll group 3 digits like this. This is one group, this is one group, this is one group, and in the first group I'll take 2 common, Now I'll take 2 outside like this, 2 outside I'll take, and then second also I'll take 2, and then third also I'll take 3. So I'll be left with 2 into 2 into 3 into third root of 1 is equal to r. When I take like this, 1 will be left, okay, under the root sign. So this is equal to 2 to the 4, 4 3 are 12. 12 into third root of 1 is 1 only, is equal to r. 12 into 1 is 12, is equal to r. So r is equal to 12 centimeter is the answer. A 20-meter deep well with diameter 7 meter is dug, and the earth from digging is evenly spread out to form a platform 22 meter by 14 meter. Find the height of the platform. So there is a well 20 meters deep. So well means it will be in the form of a right circular cylinder, that is the height is 20 meter, okay, and diameter is given as 7 meter, okay, 7 meter. Now after digging mud from this well, it is spread out to form a platform, okay, that means the platform is in the form of cuboid like this. Like this, okay, all the mud is put here on this platform. Now the resulting platform has dimension 22 by 14. This is 22, this is 14. I should find the height. What is the height of the platform found by putting all this mud here? Now what is the volume of the cylinder? Volume of the cylinder is given by pi r square into h, okay, where r is, what is r? Pi is 22 by 7. R is half of diameter, that is 7 by 2. 7 by 2 the whole square into h. Now what is the volume of this cuboid? So this is equal to base into length into breadth into height, okay. Now equate these two. Now 22 by 7 into 7 by 2 into 7 by 2. So here okay, height also we know it is 20 into 20 is equal to volume of cuboid is 22 into 14 into h. Now see what all you can cancel. 7 will get cancelled. 2 ones are 2, 2 tens are 20. Now 2 ones are 2, 2 11s are 22. So I'm left with 11 into 7 into 10 is equal to 22 into 14 into h, or h is equal to 11 into 7 into 10 by 22 into 14 is equal to h. Now 7 ones are 7, 7 twos are 14, okay, 11 ones are 11, 11 twos are 22, 2 ones are 2, 2 fives are 10. Now 5 by 2 is equal to h. 5 by 2, half of 5 by 2 is 2.5. 2 twos are 4, 1 is left, put 1 0, keep a point here, 2 fives are 10. So h is equal to 2.5. So dimension was in meter, so here also I'll get in meter. So height of the resulting platform, which is a cuboid, is 2.5 meters. Exercise 15.3, question number 4. A well of diameter 3 meter is dug 14 meter deep. The earth taken out of it has been spread evenly around it in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. So the depth of a well is 14 meter and the diameter of the well is 3 meter. So whatever mud is dug, it is put above to form an embankment. So it is like this. So that embankment width is 4 meter. So it's like this. So embankment is like this. So this is nothing but a circular ring like, okay, and these dashed edges are not visible, and the width is 4 meter. Okay, now we should find the height of the embankment. This height is what we should find. Now if you see from the top view, you get like this. A well is like this, which is 3 meters, which is of diameter 3 meters, and around it that embankment is coming like this. Okay, and the width of the embankment is 4 meter. Now here you can see there are two radius. One radius is of 1.5. This radius is 1.5 meters. Half of diameter, half of 3 is 1.5, and there is another radius, and this radius is equal to 1.5 plus 4. 4 is the width of the embankment, so 5.5. So this radius is 5.5. Now this well is in the form of a cylinder, right? So what is the volume? Volume is given by pi r square into h, okay, where r is equal to 1.5 and height is 14 meter. Okay, so volume of well is equal to pi r square into h, which is equal to pi. R is 3 by 2, half of radius 3 by 2 into h. H is 14. Now what is the volume of embankment? Volume of embankment. See this volume of embankment. If you see, this is also a cylinder, but it's hollow inside. Okay, so this portion. So here the volume of cylinder is given by pi. Okay, I'll take the bigger radius as r1. Okay, pi r1 square h minus pi r2 square h, where r1 is 5.5 and r2 is 1.5. So embankment is also in the form of cylinder, hollow cylinder. Okay, it's in the form of hollow cylinder. So that's why what is pi r square h? That gives the volume of the cylinder whose radius is r1, that is 5.5. Okay, from here till here it is 5.5. Okay, and pi r2 square h is the volume of the cylinder whose radius is 1.5. From here to here it is 1.5. Okay, I think things are clear. This is the middle path, this is the center. Okay, now volume of embankment is pi r1 square h minus pi r2 square h. So this is pi r1 is 5.5 the whole square, h we don't know, h only we need to find, h minus pi, here r2 is 1.5 the whole square into h. So here I can take pi and h as common, pi and h I'll take common, so I'll be left with 5.5 square minus 1.5 square. Now this I'll mark as 1 and this I'll mark as 2. Now embankment is made from the soil that is dug out from the well, therefore the volume of the well is equal to the volume of embankment. Okay, 1 is equal to 2. Therefore pi 3 by 2 the whole square into 14 is equal to pi into h into 5.5 the whole square minus 1.5 the whole square. So here pi will get cancelled, so I am left with 3.2 half of 3 by 2 is half of 3 by 2 is 1.5. Okay, so 1.5 the whole square into 14 is equal to h into 5.5 the whole square minus 1.5 the whole square. So here 1.5 into 1.5 the whole square is 1.5 into 1.5 into 14 divided by, so here 5.5 the whole square minus 1.5 the whole square I'll get is equal to h. So now 1.5 into 1.5 into 14, so 5.5 into 5.5, if you multiply you will get 30.25. just check it out. Okay, 30.25, and 1.5 into 1.5 when you multiply you will get 2.25. Okay, check it out. So 30.25 minus 2.25 is equal to h. Okay, now this is equal to 1.5 into 1.5 into 14, so 30.25 minus 2.25 is 28. I'll get 28 is equal to h. Now 7 2s are 14, 7 3s are 21, 7 4s are 28, then 2 1s are 2, 2 2s are 4. Now finally I'll get 1.5 into 1.5 divided by 2 is equal to h. So or h I'll get as 1.125 meters. So some multiplication and division I have skipped, you can check by yourself. Exercise 15.3, question number 5. A container shaped like a right circular cylinder having diameter 12 cm and height 15 cm is full of ice cream. The ice cream is to be filled into cones of height 12 cm and diameter 6 cm having a hemispherical shape on the top. Find the number of such cones which can be filled with ice cream. So there is a cylinder whose dimension is like this. Height is 15 meter and diameter is 12 meter. Okay, the cylinder contains full of ice cream, and this ice cream should be poured into cones such that a hemisphere is formed on the top. Okay, the cone dimension is height is 12 meter and diameter of the cone is 6 meter. Therefore the radius of the cone will be 3 meters. Okay, and also the radius of the hemisphere will be 3 meters. Now how many cones I need such that I can pour all this ice cream into these cones? That's the question. Now what is the volume of this cylinder? Volume is given by pi r square into h, where r is 6. Okay, half of diameter, that is 12 by 6, sorry 12 by 2, which is equal to 6, and height is 15 meter. And coming to this cone, what is the volume of this cone here? So this is given by 1/3 of pi r square h, where r is equal to 3 meters and h is equal to 12 meters. And what about the volume of this sphere? So volume of this hemisphere, so volume of sphere is given by 4 pi r cube by 3. So half of this will give volume of hemisphere. Okay, now we'll calculate volume of cylinder. So volume of cylinder is equal to pi r square h. So pi into r is 12 by 2. 12 is the diameter, 12 by 2 into h is 15. So this is equal to pi into 6 square into h is 15. So this many meter cube is the volume of the cylinder or the volume of the ice. I'll mark this as 1. Now what is the volume of cone plus hemisphere? Okay, this is equal to, so now volume of hemisphere is 4 pi r cube by 3, half of this. So 2 1s are 2, 2 2s are 4. So 2 by 3 pi r cube will be the volume of hemisphere, plus volume of cone. Volume of cone is 1 by 3 pi r square into h. So now this is equal to 2 by 3 pi r. So radius of hemisphere is 3. So 3 cube plus 1 by 3 pi. Radius of cone is 3 square into h. H is 12. That is height of the cone. So here what all can I take common? I can take 1 by 3 common. Okay, I can take pi common, and also I can take 3 square common. Without taking also you can do, but if I take, it will be very easy for me to calculate. So I am left with, in the first term I will be left with 2 into 3, and in the second term I will be left with 12. Okay, so this is equal to 1 by 3 into pi into 3 cube into, now 2 3s are 6, 6 plus 12. So 1 by 3 into pi into 3 cube into 18. Now this I will mark as 2. Now if I divide 1 by 2, I will get the number of cones. So 1 divided by 2, what is 1? 1 is given by pi into 6 square by 15. Okay, 2 is 1 by 3 into pi into 3 square into 18. So here pi will get cancelled. I will be left with 6 square means 6 into 6 into 15 divided by 1 by 3 into 3 square is 3 into 3 into 18. Now 3 1s are 3, 3 2s are 6, 3 1s are 3, 3 2s are 6. Okay, now 3 1s are 3, 3 6 are 18. So I am left with 2 into 2 into 15 by 6. Now 2 1s are 2, 2 3s are 6. 2 into 15 is 30. 30 divided by 3, I will get 10. So I need 10 number of cones to fill all the ice cream of this cylinder into the cones. Exercise 15.3, question number 6. How many silver coins 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimension 5.5 centimeter into 10 centimeter into 3.5 centimeter? So the dimension of the coin is, the diameter is 1.75 centimeter and the thickness is 2 millimeter. Thickness means it is the height of the coin. Okay, so in this problem all the dimension are given in centimeter, but only the thickness of coin is given as 2 millimeter. So here also I should convert this 2 millimeter into centimeter only. I can't take one dimension in millimeter and I can't take one dimension in centimeter and I can't calculate. If I calculate, I'll get wrong answer. So 1 millimeter is equal to 1/10 of a centimeter. that means 0.1 centimeter. Similarly 2 millimeter will be equal to 0.2 centimeter. So 2 millimeter means it's 0.2 centimeter. Okay, now what is the volume of this coin? Volume is given by area of the base into height, that is pi r square is the area of the base into height. Height is now pi, so r is 1.75 by 2, diameter is 1.75, half of that will be the radius, into height is 0.2. I will mark this as 1. Now many coins are melted and they are converted into a cuboid, and the dimension of the cuboid is length is 10 centimeter, breadth is 5.5 centimeter, and height is 3.5 centimeter. Now what is the volume of this cuboid? Volume of cuboid is given by length into breadth into height, length into breadth into height, which is equal to 10 into 5.5 into 3.5. This I'll mark as 2. Now if I divide 2 by 1, I'll get the number of coins. Okay, 2 divided by 1. So what is 2? 10 into 5.5 into 3.5 divided by 1 is pi into 1.75 by 2 the whole square into 0.2. So this is equal to 10 into 5.5 into 3.5 divided by pi is 22 by 7 into 1.75 by 2 into 1.75 by 2, because 1.75 by 2 the whole square is there, into 0.2. Now I'll bring all the numerator, the denominator to the numerator. When I bring that, numerator will be as it is, 10 into 5.5 into 3.5. When I bring 22 by 7 to the numerator, it becomes 7 by 22. When I bring 1.75 to the numerator, it becomes 2 by 1.75. Sorry, okay, and one more is left, that also will become 2.1.75. So into, so this 0.2 is as it is in the denominator. Okay, now 2 ones are 2, 2.1s are 0.2. Okay, this will get cancelled. Now 2 ones are 2, 2 11s are 22. Okay, now 11 ones are 11, 11 5s are 55. That means I'll get 0.5 here. Okay, 11 5s are 55. So I'm left with 10 into 0.5 into 3.5 into 7. These are left in the numerator, and in the denominator I am left with 1 into 1.75 into 1.75 into 0.1. Now what is 7 into 3.5? 7 into 3.5. Okay, not this one. Okay, 0.5 into 7. 0.5 into 7 is 7 5 are 35. 3.5 I'll get. So the above I can write as 10 into 3.5 into 3.5. So these two are multiplied, 0.5 and 7. So into 1.75 into 1.75 into 0.1. Okay, this one into any number is that number itself. That's why I have taken that one. So now you can notice one thing here, 1.75 into 2, 1.75 into 2 is 3.5 you will get. So 1.75 ones are 1.75, 1.75 twos are is 3.5. Similarly here also 1.75 ones are is 1.75, 1.75 into 2 is 3.5. So now I am getting 10 into 2 into 2 into 0.1. So 2 2s are 4, 4 10s are 40, 40 by 0.1. So 40 by 0.1 is 400. If I shift the decimal here, I should add 10 to the numerator. Okay. So answer is 400. So I need 400 coins so that I can melt and I can fill into this cuboid of dimension 10 into 5.5 into 3.5. Exercise 15.3, question number 7. A cylindrical bucket 32 centimeter high and with radius of base 18 centimeter is filled with sand. The bucket is emptied on a ground and a conical heap of sand is formed. If the height of the conical heap is 24 centimeter, find the radius and slant height of the heap. So the bucket dimension is like this. It's 32 centimeter high and radius is 18 centimeter. That means from midpoint it is 18. It's 18. So now what is the volume of bucket? Volume of bucket is given by area of the base, that is pi r square into h. So pi, what is r? R is 18. So 18 square into h. H is 32. This many centimeter cube is the volume of the bucket. And now what they have done, this bucket is emptied on the ground and a conical heap of sand is formed. So this is filled with sand. When the bucket is inverted, conical heap of sand is formed. Okay, and height of the conical heap is 24 centimeter. Okay, now I should find the radius of this conical heap and also the slant height. Slant height is this slant height is this height. Okay, now what is the volume of this cone? Volume of cone is equal to area of the base, that is pi r square into h by 3. Okay, or simply 1 by 3 times of pi r square. H is the volume of the cone. So substitute. So 1 by 3 into pi into r. R is unknown. Height is given as 24. Okay, now volume of this cylinder is equal to volume of cone. Okay, this is 1, this is 2. Whatever sand was there in the bucket, it was inverted and it was made into a cone. Therefore both the volumes are same. So 1 equal to 2. Therefore pi 18 square into 32 is equal to 1 by 3 pi into r square into 24. Now pi will get cancelled. Now 3 1s are 3, 3 8s are 24. Okay, now 8 1s are 8, 8 4s are 32. Okay, now 18 square into 4 is equal to r square. I'll get. Okay, what is the square root of r? R square is equal to 18 square into 4, or r is equal to plus or minus square root of 18 square into 4. So plus or minus, so this is square root of 18 square into 4 is square root of 18 into square root of 4. Square root of 18 is square root of 18 square is 18 only. Square root of 4 is 2. Now 18 into 2 is 36. So plus or minus 36 I'll get. I'll discard negative value because r cannot be negative. Therefore r is equal to plus 36. Okay, 36. What is the dimension? Centimeter. Okay, 36 centimeter. Now what is the slant height? So R is 36. So what is L? So you can see, so there is a right angle triangle formed in a cone. So slant height is given by, if you apply Pythagoras theorem, L square is equal to 24 square plus 36 square. Okay, so this is equal to 24 into 24 is 576, and 36 into 36 is 1024. Okay, or L is equal to plus or minus square root of, now 576 plus 1024, you get 1872. So I am skipping some steps, you can do it by yourself and check it out. Please cross verify. Now what is square root of 1872? So 1872, factorize it. 2 9s are 18, 2 3s are 6, 2 6 are 12, then 2 4s are 8, 2 6 are 12, 2 8s are 16, then again 2 2s are 4, 2 3s are 6, 2 4s are 8, then again it is divisible by 2, 2 1s are 2, 2 1s are 2, 2 7s are 14. Now this is a odd number, not divisible by 2, so it's divisible by 3, 3 3s are 9, 3 9s are 27, 3 1s are 3, 3 3s are 9, and 13 is the prime number, 13 1s are 13. So this is equal to, I can write as plus or minus square root of 2 into 2 into 2 into 2 into 3 into 3 into 13. Now square root of this number is, square root means second root of this. Okay, so I can group two numbers like this, and I can bring it outside. I can bring this 2 outside. Similarly, I can bring this also outside. I can bring this also outside. So this is equal to plus or minus square root of plus or minus 2 into 3, okay, into root 13. I'll keep it as it is. Now this is equal to plus or minus 2 2s are 4, 4 3s are 12. So plus or minus 12 root 3. So L cannot be negative, therefore I'll take L positive only. Okay, therefore L is equal to 12 root 3, 12 root 13 centimeter. This is the answer. Exercise 15.3, question number 8. Water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? So there's a canal whose dimension is 6 meter by 1.5 meter. Okay, so 6 meter and this is 1.5 meter. This is the dimension of the canal. Canal can be in circular shape also, but this canal, it is in a rectangular shape. Okay, in this canal water is flowing, and in the rate of flow is 10 km per hour. Okay, so 1 kilometer means 1000 meter. Okay, therefore 10 kilometers means it is 10 into 1000. Okay, so this is equal to 1 followed by 4 zeros, 1 by 4 zeros meters. Okay, 10 kilometer is equal to 10,000 meters. So for 1 hour, 1 hour is equal to 60 minutes. Okay, now for continuously for 1 hour water is flowing, so the rate of flow is 10 kilometers per hour, that or 1000 kilometers per hour. So the water, if it continuously flows for 60 minutes, it will be like this. Okay, So continuously 1 hour water is flowing, that means water flows for 1000 10,000 meters, that many distance the water will flow. Okay, and the width will be same, that is length is 6 and here it is 1.5 meters. So that means the total volume flown will be equal to length into breadth into height, that is volume of water flown is equal to 10,000 into 6 into 1.5. I hope you are understanding. The rate of water flow is 10,000 meter per hour. Okay, so in 1 hour the water flow will be 10,000 into 6 into 1.5. This many meter cube will be the water flown. So this is for 60 minutes. Okay, so what is for 30 minutes? For 30 minutes, what is the water flown? It's a simple cross multiplication. So 10,000 into 6 into 1.5 into 30 by 60 meter cube will be the water flown. Okay, and the water flown is irrigated. Okay, irrigated to an area. Let us say it is irrigating to a square shaped area. Okay, and they're telling that 8 centimeter of standing water is needed. That means like this. Okay, 8 centimeter. Okay, if this is 8, if this dimension is 8 meter, sorry, centimeter, they are given in centimeter. So if 8 centimeter is the standing water, what is the area? What is this area is the question. So what is this area given by? What is the volume of this given by? This is given by area into height gives the volume. So this is area into height is 8 centimeter. 8 centimeter expressed in meter, it is centimeter cube, or when it converted to meter cube, it is 8 into 0.8 meter cube. Sorry, it is 8 by 100, because 1 centimeter is equal to 1 by 100th of a meter. Okay, therefore I should divide by 10. So area of this irrigated volume of this irrigated land is A into A by 100 meter cube. Now I can equate this. I'll take this as equation 1 and this as equation 2. Both are same. The amount of water flown and the irrigated area, the volume of the irrigated area will be the same. Therefore 1 is equal to 2. Now equate 1000 into 6 into 1.5 into 30 by 60 is equal to A into A by 100. So into A by 100. Now 0 0 will get cancelled here. 3 1s are 3, 3 2s are 6, 2 1s are 2, 2 3s are 6. Now I'll get 10,000 into 3 into 1.5. If I cross multiply, the left hand side, 8 by 100 in the left hand side will go, when I take to the left hand side, it becomes 100 by 8 is equal to area. So now this I can write as 3 into 1.5 by 8 into 10,000 into 100 is equal to area. now 3 into 1.5 by 8, you will get as 0.5625. So 0.5625 into, so 10,000 into 100 means 1 followed by 4 plus 2, 6, 8, 6 zeros, 1 2 3 4 5 6. This is equal to area. So now if I multiply this one, I should shift the decimal place by 6 to the right side, 1 2 3 4 like this. Okay, 5 6 2 5. So 1 2 3 4, another 2 zeros will get. So area, or A is equal to 562,500 meter square. This is the answer. So the water flow has irrigated an area of 562,500 meter square, and the standing water on that area is 8 centimeter, or 8 by 100 meters. And if you want to convert this area into hectares, it is, you should divide by 10,000, you will get 5625 hectares. Exercise 15.3, question number 9. A farmer connects a pipe internal diameter 20 centimeter from a canal into a cylindrical tank in a field which is 10 meter in diameter and 2 meter depth. If water flows through the pipe at the rate of 3 kilometers per hour, in how much time will the tank be filled? So there is a field of a farmer, and there is a tank inside the field, and the tank's dimension is 10 meters in diameter and 2 meter in depth. So what this farmer is doing is, she is connecting a pipe from a canal, and she is making water flow from that pipe to this tank, and the dimension of the pipe is, the diameter of the pipe is 20 centimeter. So 20 centimeter means 1 centimeter is equal to 1 by 100 meter, that is 0.01 meter. Therefore 20 centimeter is point, okay, 20 by 100, which is equal to 2 by 10 meter. Okay, so this is the diameter of the pipe. Okay, and the rate of flow of water is, it's given that it's 3 kilometers per hour. That means 3 kilometer per 60 minutes. Okay, so kilo means 1000, so that is 3 into 1000 by meters by 60 minute. Okay, so the rate of flow of water is 3000 meters in 60 minutes. This is the rate of flow of water. Okay, therefore the volume of water flown will be equal to rate of flow of water into area of pipe. Okay, so 3000 into, what is the area of pipe? That is pi r square, pi into r square. So this is equal to 3000 into pi. What is r? So r we know it is 20, or 20 by, so 20 by 100 is the, okay, 20 centimeter. 20 centimeter means half of diameter. Half of diameter is 20 by 2, which is equal to 10 centimeter. Okay, 10 centimeter. 10 centimeter is equal to 10 by 100 is equal to 0.1 meter. Okay, 10 centimeter is equal to 0.1 meter. So pi into 0.1 the whole square. So this is equal to 3000 into pi into 0.1 into 0.1. So 3000 into pi, 0.1 into 0.1 is 0.01 I'll get. So 3000 into 0.01, if I multiply, so 2 decimal is gone there, so 30 pi I'll get. Okay, 3000 into 0.01 is 30. So this is the volume of water flown, that is this many meter cube of water is flown from the pipe in 60 minutes. Okay, now what is the volume of tank? Volume of tank is, so this is in the form of cylinder. So area of the base of the cylinder into height, that is pi r square into h. So that is pi. So what is the radius of the tank? That is 10 by 2. 10 is the diameter, divided by 2 gives radius. So 10 by 2 the whole square into height is 2. So this is equal to pi into 100 square, 10 square is 100. So here 2 into 2 into 2. So 2 will get cancelled. So 2 ones are 2, 2 5s are 10. So 50 pi. So volume of the tank is 50 pi meter cube. Okay, this I'll mark as 1, this I'll mark as 2. So now in 60 minutes, okay, to fill a volume of 30 pi, time required is 60 minutes. Okay, therefore to fill a volume of 50 pi, what is the time taken? So it's a simple cross multiplication. It is 50 pi into 60 by 30. This is a unitary method, by 30 pi. Now pi will get cancelled, 0 will get cancelled, 3 ones are 3, 3 twos are 6. Now 50 into 2 is 100, so 100 minutes. So with the given pipe, if the rate of flow of water is 3000 meters per hour or 3 kilometers per hour, if in that rate if the water flows, then it takes 100 minutes to fill this tank. Okay, with dimension diameter 10 meter and depth 2 meter. Now in this question, area of pipe means if there is a circular pipe like this, and if the front portion, what will be the front view? If you see from this side, it will be a circular like this, right? Okay, so what is the area of this circular region? Okay, this is pi r square. Okay, where r is the radius. So rate of flow of water into the area, into the cross section area of the pipe gives the volume, which I got as 30 pi meter cube. Okay, area of pipe is nothing but the cross sectional area of the pipe. In this question, there are some dimension given in centimeters, some dimension given in meters, and something rate of flow is in kilometers. So everything we should convert into one common value, that is in meter. Okay, only then you get the correct answer. If one dimension is in centimeter, if another is in meter, and if another is in kilometer, you will get wrong values. All you should convert into centimeters or meters or kilometers. That way only then you will get the correct answer. The next topic in this chapter is frustum of a cone. So if you take a cone and if you cut the cone using a plane like this, and at the top here if a circle is formed, and if that circle is parallel to the base of the cone, then the bottom portion is called the frustum of the cone. So in a cone, you can see the volume is given by 1 by 3 pi r square h, where r is the radius of the base of the cone and h is the height and l is the slant of the cone, and curved surface area is given by pi into r into l, where l is the slant height, and total surface area is given by pi into r square, pi r square plus pi into r into l. Here pi r square is nothing but the area of the base of the cone, and pi into r into l is nothing but the curved surface area of the cone. So we're coming to the frustum. So in a frustum, the radius of the base will be equal to the radius of the cone from which the frustum is formed, right? So here r and r1 will be the same, and at the top portion there is another circle formed, and let the radius be r2. Now since this frustum is cut from this cone, here the height will be different, that's why I have taken height as h, and also the slant height will be different. Here I have taken capital L, here I have taken small l. Okay, so in a frustum, the volume of the frustum is given by 1 by 3 pi into h into r1 square plus r2 square plus r1 into r2, and always r1 is greater than r2. Okay, and curved surface area is given by pi into r1 plus r2 into l, and l is given by, l is nothing but the slant height of the frustum. So L is given by square root of h square plus r1 minus r2 the whole square, and total surface area is given by pi into L into r1 plus r2. So pi into L into r1 plus r2 is nothing but the curved surface area of the frustum, and plus pi r square. Pi r square is nothing but the area of the base of the frustum, plus pi r square. So pi r square, pi r2 square. Pi r2 square is nothing but the area of the top of the circle, this portion. So area of this circle and area of this circle and the area of the curved surface area gives the total surface area of the frustum. In your textbook there are some worked examples. All are very simple worked examples. It's all self-explanatory. Just go through it. Similar problems are there in exercise problems. I'll be doing the exercise problems. So as you can see here, the volume is given by this formula, curved surface area is given by this formula here, and total surface area is given by this formula. So there is no derivation for this formula. You can just accept these formulas and start doing the problems, because the derivation is out of scope for 10th standard. So go through these worked examples. All are self-explanatory. I'll be solving the exercise problems only. Now exercise 15.4. Exercise 15.4, question number 1. A drinking glass is in the shape of a frustum of a cone of height 14 cm. The diameter of its two circular ends are 4 cm and 2 cm. Find the capacity of the glass. So the drinking water is in the form of frustum, okay, and the height of the frustum is 14 cm, and the diameter of the top circle is 4 cm and the diameter of the bottom circle is 2 cm. Therefore, what is the radius of the top circle here? So radius will be half of diameter, that is 4 by 2, which is equal to 2 cm, and the radius of the bottom circle is half of diameter, so R2 is 2 by 2 is equal to 1 cm. Now we should find the capacity of the frustum. Capacity means we should find the volume. How much volume does this frustum have? So volume of the frustum is given by 1 by 3 into pi into h into r1 square plus r2 square plus r1 into r2, where h is the height, r1 is the radius of the top circle, and r2 is the radius of the bottom circle, and r1 and r2, okay, into plus r1 into r2, okay. Now substitute all the values. 1 by 3 into pi into, so h is 14, okay, r1 we found it is 2, r2 is 1, and r1 into r2 is 2 into 1. Now 2 square is 4, 1 square is 1, 2 into 1 is 2, so 1 plus 4 plus 1 plus 2 is 7. So 1 by 3 into pi is 22 by 7 into 14 as it is into 7. So this 7 and this 7 will get cancelled. 22 into 7 I'll get 308. by this 3 centimeter cube is the volume of the frustum. So we can convert this improper fraction into, we can convert this improper fraction into mixed fraction also. Now 308, if you divide by 3, 3 ones are 3, so you get 0 here, and you take this 0, but still you can't divide, therefore I'll take this 8 also by putting 1 0 here. I'll take this 8. Now 3 2s are 6. Now 8 minus 6 is 2. So 308 by 3 is equal to 102, 2 by 3. Okay, this many centimeter cube. You can leave the answer at this point only, 308 by 3 centimeter cube. Still you will get full marks, you don't have to worry. This problem I can do in another method also. So in another method, what I'll do is, I have drawn the frustum, and what I'll do is I'll extend the slant height. I'll extend the slant height and I'll make a cone. Let the slant height meet at this point, and now you can see that there are two cones formed. One is a big cone and one is a small cone. So now volume of the frustum. So volume of the frustum is given by volume of big cone minus volume of small cone. So volume of big cone is given by 1 by 3 pi into, I'll take radius of this cone as r1 and h as h1. Okay, so this is the height of the big cone. Okay, this is the h1. Okay, and minus what is the volume of small cone? Small cone is given by 1 by 3 pi into r2, where r2 is the radius of the small cone and h2 is the height of the small cone. So this is the h2, height of the small cone. So now I should find r1 and r2 is already known. I should find h1 and h2. Okay, now the two cones are similar, therefore the ratio of the radius will be equal to ratio of the height. Okay, r1 by r2 is equal to h1 by h2. Now what is r1? R1 is half of the diameter, that is 2 by 2. We already know it is r1 is 2. In the previous method only we came to know r1 is 2 centimeter. So 2, r2 is 1 centimeter. So this is equal to h1 by h2. So when we cross multiply, I'll get 2 h1 is equal to 1 into h1 is h1. So 2 h2 is equal to h1. Okay, 2 h2 will be equal to h1. Okay, now I'll mark this as 1. Now, so in the diagram you can see that the difference of h1 minus h2 is equal to 14. Okay, now I substitute 1 here. h1 is 2h2. 2h2 minus h2 is equal to 14. Therefore 2h2 minus h2 is 1h1. 1h2. 1h2 is equal to 14, or h2 is equal to 14 centimeter. So h2 I'll get as 14. Now I'll mark this as 2. Therefore I'll substitute this in A. Okay, so h1 minus h2 is 14 is equal to 14. So h1 is equal to 14 plus 14. I'll take this 14 to the right hand side. So h1 I'll get as 28 centimeter. So h1 is 28 centimeter. Now I'll substitute all this value here. So this is equal to, now I'll take 1 by 3 pi as common, and r1 h1 is left in the first term minus R2 H2 in the second term. So this is equal to 1 by 3 into pi. So R1 is 2, H1 we got as 28. So 28 minus R2. What is R2? R2 is 1 into H2. H2 is 14. Okay, so here 1 by 3 into pi. So into 2. So 28 I can write as 2 into 14. 2 into 14 minus 1 into 14 is 14 only. So 1 by 3 pi. So I have made one small mistake. So formula of a cone is 1 by 3 pi r square h. Okay, so this is r square h, this is r square h, r1 square h, this is r2 square h2. So this is 2 square into 28, this is 1 square into 14. So 2 square into 2 into 14. Now 1 by 3 pi into, now again I'll take 14 as common between these two. So I'm left with 2 square into 2 minus 1. So 1 by 3 into pi into 14 into, so 2 square into 2 is 2 to the power of 3 minus 1. So this is equal to 1 by 3 into pi into 14. So 2 cube is 8. 2 into 2 into 2. So 8 minus 1. So now I'll substitute the value of pi. So 1 by 3 into 22 by 7 into 14. 8 minus 7. 8 minus 1 is 7. So this and this will get cancelled. 22 into 14. 22 into 14 I'll get 308. 308. That step I've skipped. So 308 by 3. So 308 by 3 we got as 102. 2 by 3. In the previous method only we got this one. So 308 by 3 gives 102 into 102 2 by 3 centimeter cube is the volume. And that completes this problem. You can leave the answer at this point also, 308 by 3 centimeter cube. So it's perfectly correct. Even if you leave the answer at this point, you will get full marks. You don't have to worry. Okay. Exercise 15.4, question number 2. The slant height of a frustum of a cone is 4 centimeter and the perimeter, that is circumference of its circular ends, are 8 centimeter and 6 centimeter. Find the curved surface area of the frustum. So curved surface area of the frustum is given by pi into r1 plus r2 into L, where L is the slant height. So L we know, so but we don't know r1 and r2. So the radius of the bigger circle is r1. So I'll draw perpendicular like this from this point, and from this point I will draw perpendicular. Now 6 centimeter is the diameter of the lower circle and 18 centimeter is the diameter of the top circle. So 2 pi r1 is equal to 18. Okay, what is the circumference is given by? Circumference is given by C is equal to 2 pi r. Okay, this is the formula for circumference. So if r1 is the radius of the top circle, so 2 pi r1, if r1 is the radius of the top circle, 2 pi r1 is equal to 18. So now therefore r1 is equal to 18 by 2 pi. So 2 ones are 2, 2 nines are 18. So this is equal to 19 by pi. So similarly 2 pi into r2 is equal to 6. So where r2 is the radius of the lower circle, the base. Okay, so now r2 is equal to 6 by 2 pi. So 2 ones are 2, 2 threes are 6. So this is equal to 3 by pi. So r2 is 3 by pi. So if from midpoint I'll draw one perpendicular like this. So this is r1, okay, which is equal to 3 by pi. 3 by pi. Now r1 r2 both are known, so substitute in this formula. So curved surface area is given by pi, that is pi into r1. R1 is 9 by pi plus r2 is 3 by pi. pi into L. Slant height is 4 centimeter it is given. So this is equal to pi into, so LCM of of pi and pi is pi only. So in the numerator 9 plus 3 I'll get 9 plus 3 into 4. So here pi and pi will get cancelled. 9 plus 3 is 12. 12 into 4. 12 fours are 48. 48 centimeter cube is the curved surface area of the given frustum. Sorry, this is centimeter square. So always area will be in centimeter square or meter square this way, or millimeter square. Only volume will be in centimeter cube or in meter cube that way. Okay. Exercise 15.4, question number 3. Fs, the cap used by the Turks, is shaped like a frustum of a cone. Figure 15.24. If the radius on the open side is 10 centimeter and the radius of the upper base is 4 centimeter and its slant height is 15 centimeter, find the area of the material used for making it. So this is a cap, therefore the lower portion is hollow, there's no material there, only the curved region is there and the top region is there. So what is the area of the curved region here? So this area is given by pi into R1 plus R2 into L, where L is the slant height. And what is the area of this top circle given by 1 by 3? Sorry, this is pi R2 square, where R2 is the radius of the top circle. So what is the total area? Total area is equal to area of circle, that is top, plus curved surface area. Okay, so area of circle is given by pi r square and curved surface area is given by pi into R1 plus R2 into L. So this is equal to, now I can take common factor, I can take pi. So R square plus R1 plus R2 into L. So this is equal to pi. What is so this is R2, okay, R2 square. So what is R2? R2 is the radius of the top circle. So that is 4 square plus what is the radius of bottom circle, that is 10, and R2 is 4. So what is slant height? Slant height is 15. So pi into 4 square is 16. 4 4s are 16. So plus here 10 plus 4 is 14. 14 into 15. So this is equal to pi into 16 plus 14 into 15. 14 into 15 I'll get 210. Check it out. And pi into, now 210 plus 16. So 220, 226, 226. So now I'll substitute the value of pi, 22 by 7 into 226. Okay, so 22 into 226, I'll get 4972. I'll leave it to you to calculate. Divide by 7. Now 4972 divided by 7. 7 sevens are 49. So 0. Then I'll take these two. Then 7 tens are 70. So I'll get 2 remainder. So it is 7 10. Remainder is 2. Divisor is 7. So this is 7 10. 2 by 7 centimeter square is the total area. You can leave the answer at this point only. 4972 by 7 this many centimeter square. So even if you leave the answer at this point, you will get full marks, so you don't have to worry. And that completes this problem. Exercise 15.4, question number 4. A container opened from top and made up of a metal sheet is in the form of a frustum of a cone of height 16 centimeter and radii of the lower and upper ends as 8 centimeter and 20 centimeter respectively. Find the cost of the milk which can be completely filled in the container at the rate of rupees 20 per liter. Also find the cost of the metal sheet used to make the container if it costs rupees 8 per centimeter square. Take pi as 3.14. So the figure is like this. There is a frustum of a cone. The container is in the form of a frustum of a cone whose top radius is 20 centimeter and bottom radius is 8 centimeter. So if we fill this container with milk, what is the cost of the milk they are asking? So before finding the cost of the milk, I should find the volume of the frustum. First understand the question and then proceed. Okay. So volume of the frustum is given by 1 by 3 into pi into h into r1 square plus r2 square plus r1 into r2, where r1 is the radius of the bigger circle and r2 is the radius of the smaller circle. So this is equal to 1 by 3 pi into h is 16. So into 16, r1 is 20 square plus r2 is 8, so 8 square plus r1 into r2, so 20 into 8. So this is equal to 1 by 3 into pi into 16. So 20 square is 2 2s are 4 followed by 2 zeros plus 8 8s are 64 plus 2 6 are 8, 2 8s are 16. 2 8s are 16, so 160. So this is equal to 1 by 3 pi into 16. So 400 plus 160 is 560. 560 plus 64, 4 6 6 12 carry 1 624. So into 624. So now this is equal to 1 by 3. So pi they are told to take as 3.14 into 16 into 624. 624. Now 3 1s are 3, 3 2 3 3 2s are 6, then 3 0 3 8s are 24. So this is 3.14 into 16 into 208. So this you will get as 10,449.92 centimeter cube. Okay, this is the volume. So multiplication I have left to you. So now 1 liter is equal to 1000 centimeter cube. Okay, therefore this is equal to 10449.92 by 1000 liters. Okay, so this is equal to 10.44992 so liter. I'll just for division I'll just shift the decimal point by 3 places, because in the denominator there are 3 zeros, therefore I can shift the decimal point by 3 places. So this is the volume in liters. Now given that, what is the cost of milk for 1 liter? For 1 liter the cost is rupees 20. Therefore for 10.44992 liters, what is the cost? So just cross multiply. So when you cross multiply, you will get 10.44992 into 2 into 20 by 1. So this you will get as 20.899.84. Sorry, it's 208.99 2.84 you will get, or approximately it is rupees 209. Okay, so in the textbook the answer given is 209. It's an approximate answer. Exact answer is 208.9984 rupees. So in the question they have also asked to find the cost of the material used to manufacture this container. Okay, so before finding the cost I should find the total area of the container. So total area of the container will be curved surface area of the container plus area of the base. Okay, so curved surface area of the container is nothing but the curved surface area of the frustum, that is which is given by pi into r1 plus r2 into L plus area of the base is given by pi r2 square, where r2 is the base radius of the base and r1 is the radius of the top circle. Now what is L? L is the slant height. So L is defined by L is equal to square root of h square plus r1 minus r2 the whole square. So this is equal to, what is h? In the diagram you can see h is 16. So 16 square plus r1 is 20. So 20 minus r2 is 8 the whole square. So this is equal to 16 square plus 20 minus 8 is 12 square. So 16 square is 256 plus 12 square is 144. Please check it out. And 256 plus 144 is 400. So square root of 400 is plus or minus 20 I'll get, but I'll take only positive value because the length can be only positive. So the slant height is 20 centimeter. So now substitute here all these values. So this is equal to, so pi I'll take common factor. So pi, so I'm left with r1 plus r2 into L plus r2 the whole square. Okay, like this. Okay, so this is equal to pi. Now r1 plus r2 is 20 plus 8 into L. L is 20 plus r2 radius of the base, that is 8 square. So this is equal to pi into 20 plus 8 is 28 into 20 plus 8 is 64. Okay, so 28 into 20, 28 into 20, so 2 8s are 16, 2 2s are 4 plus 1 5, so 56, 560. So pi into 560 plus 64, 560 plus 64 is 4, 6 6 12, carry 1, 624. So this is pi into 624. So pi that told to take as 3.14 into 624. So this you will get as 1959.36 centimeter square. So calculation I am skipping, it is left to you, please check it out. Now given that the cost of 100 centimeter square of that metal sheet cost rupees 8, therefore 1959.36 cost how many? Just cross multiply. So this is equal to 1959.36 into 8 divided by 100. So this you will get as 156.74 okay rupees. So arithmetic calculation I skipped. This is the answer given in the textbook and we got it, and that completes this problem. Exercise 15.4, question number 5. A metallic right circular cone 20 centimeter high and whose vertical angle is 60 degrees cut into two parts at the middle of the height by a plane parallel to its base. If the frustum so obtained be drawn into a wire of diameter 1 by 16 centimeter, find the length of the wire. So here there is a cone whose height is 20 centimeter and it is cut into two parts at the middle of its side by a plane. So that means the height of the frustum will be 10 centimeter and the height of the shorter cone so obtained will be equal to 10 centimeter. Okay, in this way it is cut. I will name the cone as ABC. This is a two-dimensional diagram, and it is given that the vertical angle is 60 degree, that is angle A is 60 degree. Okay, now at A, if I draw one perpendicular to the base like this, now this angle will be equal to 30 degree and this angle will be equal to 30 degree. Okay, now I will mark this point as D, this point as E, and this point as F. Okay, now the frustum so formed, so this portion is the frustum, right? The frustum so formed is converted into a wire whose diameter is 1 by 16 of a centimeter. Okay, I should find the length of the wire. Now I am drawing this wire in the form of a cylinder, so therefore I should find the height of the cylinder. Okay, like this. I will mention the height as capital H. Now since the frustum is converted into a wire or a cylinder, okay, the volume of frustum will be equal to volume of cylinder or wire. Okay, what is the volume of frustum given by? Volume of frustum is given by 1 by 3 pi into H into R1 square plus R2 square plus R1 into R2. Okay, where R1 is the radius of the base or the bigger circle. Here it is DC will be the R1 and R2. Now this point I will mention as G. So R2 is GF. R2 is the radius of the top circle of the frustum. Okay, now this is equal to volume of the cylinder. Volume of the cylinder is given by area of the base. Area of the base is pi r square into H. Okay, now here I can cancel pi and pi I can cancel, so I am left with 1 by 3 R1 square plus R2 square plus R1 into R2 is equal to, so here what is the radius of this cylinder here? So diameter it is given as 1 by 16. Diameter is 1 by 16. Therefore R is equal to half of that. So half of that means 1 by 2 into 1 by 16. So this is equal to 1 by 32 I will get. Okay, the radius of the wire will be 1 by 32. So volume of the cylinder is 1 by 32 the whole square. So pi will get cancelled. I will be left with 1 by 32 the whole square into H. So H we don't know, and we still don't know what is R1 and R2. Okay, now in the diagram we can see what is tan of 30 degree. Tan of 30 degree. Tan is opposite by adjacent. So here opposite side with respect to angle A, tan 30 is CD by AD. Okay, CD is R1. What is AD? AD is the height of this bigger cone, that is 20 centimeter. So what is tan 30 degree? Tan 30 degree is 1 by root 3. Okay, so 1 by root 3 is equal to r1 by 20. Therefore, r1 is equal to 20 by root 3. Now, what is r2? Now, cone AEF and cone ABC are similar. So they are similar, that and hence the ratio of the radius will be equal to ratio of the height, that is r1 by r2 will be equal to h1 by h2. Okay, if I cross multiply, so now substitute the values of r, h and h2. So r1 is 20 by root 3, 20 by root 3 by r2 is equal to h1 by h2. Height of the bigger cone is 20, height of the smaller cone is 10. So here 0 0 will get cancelled, 2 will be left. Now 2 1s are 2, 2 10s are 20, and after cross multiplication I will get r2 is equal to 10 by root 3. Okay, now substitute the values of r1 and r2 here. So this is 1 by 3 into r1 is 20 by root 3 the whole square, plus r2 is 10 by root 3 the whole square, plus r1 r2. So 20 by root 3 into 10 by root 3. This is equal to 1 by 32 into 1 by 32 into h. So 1 by 3 into 20 the whole square is 2 2s are 4, 400 by root 3 the whole square is 3 only, plus 10 the whole square is 100, root 3 the whole square is 3, plus 2 10s are 20 into 10 is 200 by root 3 into root 3 is just 3 is equal to 1 by 32 into 1 by 32 into h. Okay, now 1 by 3. So here 3 is the LCM. So 400 plus 100 plus 200 is equal to 1 by 32 into 1 by 32 into h. So here 1 by 3 into 400 plus 100 plus 200 is 700. 700 by 3 is equal to 1 by 32 into 1 by 32 into h. Now if I cross multiply 1 by 3 into 700 by 3 into 32 into 32 is equal to h I will get. Now if I evaluate this one, I will get h is equal to 79644.44 centimeter. And if I want to convert this into meter, h will be equal to 7964.44 meters, because why? 1 meter is equal to 100 centimeter. So to convert it into meter, I should divide by 100. Therefore I will get height of the cylinder or the length of the wire as 7964.44 meter. And that completes this problem and this exercise. The next topic is optional exercise. This is not from examination point of view. They have clearly mentioned these exercises are not for the examination point of view. They are given just for your understanding. You can try by yourself. I won't be attempting. And coming to the summary, in this chapter you have studied the following points. To determine the surface area of an object formed by combining any of the two of the basic solids, namely cuboid, cone, cylinder, sphere and hemisphere. To find the volume of objects formed by combining any of the two of a cuboid, cone, cylinder, sphere and hemisphere. So lot of problems we have done, and that completes this chapter.